Good evening, everyone.
Good evening, sir.
So others are joining. Do you have any Did you have any session before this session or?
So this is the first session for week 5.
Yes, sir. This is the first one, sir.
This is the first one, sir.
Okay. Fine. But you guys have studied, right? So
We have,
yes,
we have gone through
Not
couple of
completely,
weeks.
sir.
Not completed, sir.
not completely.
And all the videos are around 45 minutes each. So
Correct, sir.
Okay.
Very lengthy, and then the first video itself is a very bouncer of, functions of continuous random variable.
exactly, sir. I think we are on the same page, sir.
The first video itself is a very bouncer, sir. Please discuss the concept, sir.
Okay. Fine. So okay. Actually, today's session is solved with us. But what I did is we have some questions there, which are.
Yeah, in tutorial we have some questions, sir.
Huh?
There is a tutorial also in week 5. We have tutorial videos also.
Tutorial videos are just like all the tutorial questions are there, right? Some of the
Right.
questions are there in the tutorial videos, same questions. The thing is only that is explained in the video. Okay.
So from our side, request is that today we should discuss concepts, sir. Please explain concepts, and then
Yeah.
tomorrow we can solve solve with us, or day after tomorrow we can have.
No, tomorrow is the deadline, right? I don't know that.
No. This time it is Friday, sir, because we had
Yeah.
paper on, sir.
So
We
10th
had
is the deadline, sir. 10th
10th is
June is
deadline,
the
sir. Friday,
deadline. Sir.
Friday.
We have Friday is the deadline, so we can
Deadline.
have proper discussion, sir. There
Yes,
is no
proper
hurry.
discussions, and then we can have solve with us tomorrow or day after tomorrow.
So why? Because we are forcing on this thing, because this is a basic concept going to use in next, I think, couple of weeks, I think so.
Yeah,
right? So
from 7th onwards.
it has to be proper. I think we should be using this properly, sir. That's why.
Okay. Understand. So because your quiz was there, that's why that deadline is extended for Shash 2. That's
Yes, sir. Exactly.
correct, right?
Yeah.
Okay, understand. So how, I don't know, like how we are going to discuss, how you wanted me to discuss with the questions, or only just whatever's
So
there.
topics, sir, like initial, in the first lecture itself, we are using the uniform distribution and their function, how it behave with the function, and also distribution.
Yes, functions of continuous random
yeah, sir.
variables, sir.
That is the
you
thing,
can
sir.
take the solve with us today, or you can schedule the concept session other day. So this can be possible if today you can schedule solve with us.
Okay, one minute, just a minute. I'll just open.
I think tomorrow also we have a session, sir. I just saw calendar, so calendar has been updated. So we can have solve with us tomorrow or day after tomorrow. Today, let us have a concept discussion, sir. In the process, we can solve couple of questions to clarify the concept, but it is much needed. It is much needed to discuss the concept, sir.
So regarding week 5, right?
Yes.
So there are like functions of a random variable, continuous random variable, expectation of a continuous random variable, and there is a joint distribution between discrete and continuous.
Yes, these are the only 3 topics which have been covered.
Okay, correct. So what we can do is, what I'll tell you is, we'll just go through the activity questions in each week, okay? And while solving those activity questions, we'll discuss the, the concepts in that week. Will that be okay? What I'm assuming is, hello? Am I audible?
Yes, sir.
Yes,
you're audible, sir.
Yes, sir.
Okay. So just if I do all the all the concepts, whatever sir has did, right? So it will be similar that you can watch the video right directly there. So we can just what I'm thinking is, maybe I've seen some videos, right? At least 1 or 2 videos, like at least the continuous what is the continuous random variable, and then what is the expectation of a continuous random variable, like the functions
Yes,
of
sir.
random variable, right? Okay, so okay, maybe we'll do that one. So most probably, okay, if the deadline is extended, then we can have this solve with us tomorrow also, or day after tomorrow, whatever, it's fine. Okay.
Sir, I have a concern that regarding this solvers and all the things, just mute ourselves, the student. Don't give us permission to unmute for first 1 hour. because you are explaining the concepts and all that, and many of us are asking the questions, so it will stress the session
True,
by
sir.
3 and 3:30, and so we are working unable to watch a 30-minute session for stats and math both.
We solve with the sessions you're saying, right?
No, sir. All the mainly the
Yes, sir.
in which you are explaining the concepts now. That
Okay.
session, please
Okay.
mute all of us and don't give us permission to
Okay.
unmute till
Sir,
1 hour when you
yes, sir.
explain the
Yes, yes,
concept.
sir. Yes, sir.
Yes, sir. Addition to this thing, sir,
Uh.
one more suggestion I just want to give here. I don't want to disturb anyone.
Uh.
Suppose you are explaining some question with your approach. Until unless you complete your approach, sir, do not let anyone else to interrupt in between and just.
Exactly,
So what,
exactly.
sir?
Very
There,
true, very
sir.
true.
Actually, I'm not that much good in the statistics. Okay, so like when we go through the video, right, sir? It's the same thing. You see so many things in together,
Correct.
Mm.
Correct.
and it will just stretch. Video will just get stressed, sir.
Sir, it takes 3 hours. It's
Yeah.
like for us, working professional, it is quite tough. See, live sessions are very easy, but we would not be able to attend all the live sessions. So only option for us to watch the YouTube. So
Recordings.
the recordings, that is like 3 hour session. I don't wanted to miss. We just wanted to learn from the instructors. So initial session, we want at least what you explain, let we get it into her head. Then later on, you can encourage the questions. Okay, so that people who are watching later also peacefully, we can watch at least the concept what you're teaching, and then we can watch the whatever doubts they are asking. So
Very true, sir. This we have been requesting since many terms, sir, but this is not happening.
because
Okay.
that's correct, sir. Live session is like interaction must be nice, but first initial 1 hour at least your concept explanation will be very good for us. Like people who watch it later also, it will be very very useful. So dragging and watching for them in the 3 hours, it's not of that use.
Okay. 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 Okay.
Thank you so much,
So
sir.
you cannot like muting. I don't think it's a good option. Like you can those who have problems in between, they can raise their hands and they can ask their questions.
Okay. So yeah. So what we can do is in between. So while I am explaining, don't. Okay. I actually
Yeah,
I
you
don't
can
like
you
to
can
mute
yeah.
all this things, but it's okay. But their problem is also genuine that somebody if is interrupting in between, then there will be a like, the flow is not continuous, right?
Yes,
That
that I
is
understand. That's why I'm
So
saying that those who
concern
have
of all the
problems, they
people.
can.
okay, then what we can do is while I am explaining, please do not speak. Just raise your hands and keep calm. And when I'll
Yeah, you can call out the
ask you,
names.
yeah,
Yeah,
fine. That will is fine.
yeah, yeah.
Okay, so you are able to see my screen, right?
Yes, sir.
Okay. You guys have gone through these things, right? CDF of a random variable and this. These are the
The
slides.
screen is not visible.
Is it?
The screen is not visible now.
Okay. Okay. So I'll share my screen. So before going there, you guys understand about CDFs, right? And PDFs of a the continuous random variable. You know that thing, right?
Yes, sir.
Okay. So because this lecture starts with functions of a random variable. So before going to the functions of a random variable, you should understand, or functions of a continuous random variable, you should understand uh, the properties of PDF and properties of CDF. Okay. So now I'm assuming that you guys know what are the properties of CDF and PDF. So we start with functions of a random variable, correct? Okay. So in statistics one, you guys have already studied functions of a random variable, correct? But here we are going to study functions of a continuous random variable. It is exactly similar thing. So suppose x is a random variable, right? X is a continuous random variable, which can which can be a continuous random variables. Uh, there might be the amount of water in a glass, right? Or you can say amount of sugar. So all of this or weight of a person, these are all continuous random variable, right? Or continuous variables for that matter. When it becomes random variable, since it will change the numbers, right? And then it will become a continuous random variable, correct? So now there are certain examples here of a continuous random variable. So suppose x is uniform in 0 and 1. So this is a continuous random variable, which is uniform continuous random variable. So do you know what is the PDF of this random variable? Suppose x is uniform 0 comma 1. So uh, okay, there will be two uniforms, right? One is continuous random variable, continuous uniform, and one is discrete uniform. How can we differentiate between two? So when there are this brackets are there, so square brackets are there, that means it is a continuous uniform, and when there is a curly brackets are there, then that is called as a discrete random variable. So what is the PDF of this x? So we can actually we can denote this PDF by this notation, right? Fx of x, small f x of x. So you know this is a continuous random variable, and we know that for uniform continuous random variable, the PDF is given by 1 upon b minus a. So everybody knows about this, right?
Yes, yes.
Everyone, okay, fine. So 1 upon b minus a. So this is a and this is b. So in this interval a and b, so what is here? How can we write here? So 1 minus 0, right? 1 upon b minus a between this interval when x takes values between 0 and 1. And out of this interval, everywhere it is 0, right? So it is 0 otherwise. So this is what? This is a PDF of x, correct? Now what is the CDF of x and how to find the CDF of x? So CDF of x is denoted by fx of x, correct? Now, how can we find the CDF of x? So we can find actually by using integration. Generally, we'll find by using the integration, but we have some formulas here in this lecture. In the first lecture, I think when there is a continuous monotonic equation, then there is a way to find the for the function of a continuous random variable, right? Now, how can we find the CDF of this random variable? By using this PDF. Now it can be the integration between minus infinity to plus infinity, right? Fx of x dx. This is how we are going to find the CDF of a random variable, correct? Now, but our x is actually is uniform between this interval. So otherwise it is 0. So we can actually split this PDF into three intervals. So minus infinity to 0, fx of x dx plus 0 to 1 fx of x dx plus 1 to infinity fx of x into dx. Now here it is 0, right? Between minus infinity to infinity, fx of x is 0. So this will be so I'm going to replace here only. So this is 0 here. Here between 0 to 1, what is my PDF? It is 1 upon 1 minus a. So here it is only 1, right? And plus and more like greater than 1, it is again 0. So it's 0. So now the integration of these two things is 0. So this is not there, this will be cancelled out. So only remaining is this one, right? 1 into dx. So what is, okay, what is this actually? What is this coming? This 1 dx. So is this a
X.
CDF or is this so it is a property of a CDF, right? In that interval, the integration of the PDF, right? So it will be equal to 1, correct? So sum of the all the probabilities equals to 1. This is given by here. So if you wanted to find the PDF only, CDF only, how can you find?
Just put the integrator and put the limit.
Integ-
I think
Integration.
x.
So
Integration of
instead of
this
this
is
f
x.
of x, yeah. So here 1 upon b minus a, right? And we are not going to put this limits here. So it will be what?
A to x.
Hmm?
Uh, the limits will be a to x.
Sorry, sir, could you repeat please, sir, this line? The
So
earlier part was okay. The earlier part was okay. The two
okay.
parts of integration.
So that integration what we did earlier is to find that the cumulative probabilities of a continuous random variable
minus infinity to plus infinity. Yes.
plus infinity, it should be equal to 1, right?
Yes.
That was the later part. But if you wanted to find the CDF of x, so which is a uniform random variable, how can we find that?
So that f of x will be probability of x less than equals to small x. So it will be the lower bound. It will be a. Suppose the lower bound is a, or here it is 0. So 0 to x f1 dx.
X minus a by b minus a.
So we can go from minus infinity to a plus
but
a.
Okay,
A
minus
to
infinity
B.
to minus infinity to, so
A.
that same thing, right? Minus infinity to a.
Yes,
So,
sir. Plus
okay.
a to b and then b to infinity.
So this is generalized equation we are going to actually find out. This is not for this uniform random variable. Okay. So it will be again here fx of x dx.
So you're trying to find the cumulative distribution function.
Yes.
Yeah, cumulative distribution function for a
Then
generalized.
Then why you are doing minus infinity to a to b? Because that will give me just one. It
Okay,
is just summation.
So yeah, again it will give one, right? But 1 minute.
Yes.
Just okay. What? So leave about this for this uniform random variable. Generally, it should be 1 upon b minus a, right? Between a to b.
Yes.
Correct.
Yes.
Now this is my PDF for a uniform random variable.
Yes.
Correct.
Now when I'm trying to find the CDF,
Find the CDF,
then it is I'm doing actually the probability x less than equals to some small x.
Yes.
So my
so if you
upper
do it
limit will
again,
be x, small x.
Yes,
yeah.
sir.
So
So it will be a to x f of x dx. That is a to x 1 by b minus a dx.
So f of x is actually
A
probability
to
that
x, yeah,
x should be less than x, right?
yes. So it will be a to x integration
into
1 by b minus a dx.
Yeah, so it should be like this, right?
Yes, sir.
Dx. Okay. So this is the CDF. I think you guys have studied this in the previous week, right?
Yes, sir.
So here, so 1 upon b minus a is a constant. So it will be a to x into 1 dx. So it should be 1 upon b minus a from a to x. Sorry, if integration of 1 is x, right? So x from a to x. So it should be x minus a upon b minus a. That should be your CDF of a random variable. Fine.
Yes.
So this is for a one random variable, right? Now, suppose my y. Okay, again we'll take the same example. So x is uniform in this interval a comma b. Okay. Now y is equals to, let's say, 2x. So is this a function of a random variable?
Yes, sir.
This is the function of a random variable, right?
Yes.
Or
Yes, sir.
okay. Now can you can you find the PDF of y? How to find the PDF of y?
So can I say?
Hmm?
Can I say?
Yeah.
Okay, so your first step is to find the range of y. Like
So yeah, so here x is having, first of all, x is your random variable, right? So this range is, so range of x is between
Minus
a, no a to b, right?
Yes.
to a to b.
Because okay, first of all we'll find the what is PDF of x. So what is PDF of x? Since it is a uniform random variable, the PDF of x will be equal to
1
upon b minus a, right? Between a to b, and it is 0 otherwise. So this is my PDF of x. So that means what is the range? So range is here, right? In this interval a to b. correct? And your function of y is y equals to 2 times x. So my range of y will become, or what will be the interval of y? So when x takes
2A
value
to
a,
2B.
right? So correct. So when x equals to a, y equals to 2a, right? And when x equals to b, y is equals to 2b.
2.
So what? So from that, what we can say that, so y is varying between
2 and 2.
2a,
2A to 2B.
2a and 2b, correct? Okay. Now, now I found out the range of a random variable. Now, if this is a range, then can you find the PDF of x? Sorry, PDF of y now.
so first we have to find the CDF,
Hmm.
and from there we can move to PDF.
So, can you find directly the CDF of y?
You must have PDF.
Yes,
Then
because
we will integrate and
less
get
than
PDF.
less than 2a will be 0 and greater than 2b will be 1. We have to find in between.
Hmm.
2a to a and b to b, I think.
Okay. First of all, we'll try to draw a support. Okay, support for x and support for y. So, mm, since x is there, right? Let's say x is between a to b, correct? So in that case, y is varying between what?
2A to 2.
So let's say this is my y, which is a function of a random variable. I can write it as g of x is equals to, correct, which is equals to 2x. So my y varies from, okay, these intervals are not that. So okay, 2a to 2b, correct?
Yes, sir.
Now can you find the CDF of y here? I, so you guys are audible? No, 1 minute. See, hello, am I audible?
Yes, sir.
Yes,
yes,
Yeah.
sir, yes, sir.
So okay, the thing is, okay, maybe then we can, okay, okay, we'll see then. So here you found out. So in this case, right? So x is uniform between 0 and 1. You have found out the range between 0 and 2, right? Now how to find the CDF of y? So you have to integrate between this 2x is less than or equal to y, correct? Same formula which you applied for the function. So if you are able to see here, can you able to find the same thing here? Suppose, see, if you are able to find the CDF here, right, then it will be easier for you to find any function, for any other function. So let's say fy of y, that is what CDF, right? So what is the meaning of this CDF?
Probability of y is less than equal to y.
Small y, right?
Yeah.
Capital Y
Yes,
is
sir.
less than or equal to small y. Now here, what is your y?
2x.
Y is
2x
2x, which is less than or equal to
y.
small y.
small
Small
y.
y.
So how to find this integration? 2x is less than or equal to small y.
Probability of x less than equal to y by 2.
Hmm.
Then we will
So
integrate
okay,
from,
I can write, say, this thing as probability that x is less than or equal to y by 2,
yes, sir.
right? And you have to integrate from where to where? Since x is less than or equal to y by 2, so
A to Y by
in this case, a to y
Y
by
by
2, right? See, why we are doing this, because x is less than or equal to y by 2. So say, what is my range of x?
A to B.
A to B, right?
Yes.
So in this case, let's say in uniform of x, x is uniform between A to B. So if I wanted to find the probability that x is less than, suppose some number is there, let's say small x, which is there in between A to B, how we are going to find that probability? We'll just integrate between
A
A
to
to
B.
small x, A to small x,
Sorry,
right?
A to small x, right?
Correct. To
Yes.
find this probability. But in this small, instead of this small x, what we are having here, small y by 2, right? You're
Yes, sir.
understanding this?
Yes, sir. Yes, sir.
Okay. So I can write between from A to small y by 2, and what should be here? Correct. This is okay.
Yes, sir.
Okay. So here A to y by 2. Now if x of x is what? Since this is a uniform random variable, right? This is the PDF of x. What is the PDF of x?
Yes.
1 by b minus
1 by b minus
1 by B
1
minus
upon b
B
minus a
minus A
into dx.
dx.
So what will be the integration of this integral? So 1 upon b minus a will be outside since it is a constant, and
y by 2 minus.
so x, right? Integration of dx is x, and the limits will vary from a to y by 2. Now 1 upon b minus a, here it's y by 2 minus
A.
a. Correct?
I have a doubt.
Huh.
Or rather, I did not understand this limits as to why you set it as a to y by 2. Can you explain that bit once again, please?
Yeah, okay. So, okay. So, sir has solved using numbers, right? We'll go by numbers. So, x is uniform between 0 to 1, right?
Yes.
So, y is varying from now
0 to 2.
0 to 2. Now, fy of y is probability that capital Y is less than or equal to small y.
Yeah.
Right? Now, probability that 2x is less than or equal to y, that you understand, right? Because we
Yes.
are,
Yes.
then x is less than or equal to y by 2, that also you understand, right? That
Yes.
2 goes that side. Now, we are integrating that x from y by 2, x to y by 2, right? So 0 to y by 2.
Yeah. No. Sorry, that is the bit. X
That
is less than or equal to y by 2.
Hmm.
That is there, but how does it translate as limit to 0 to y by 2 is what I'm actually struggling with.
Okay, fine. So here you are seeing that x is varying between 0 to 1, right?
Yes.
So lower limit of that x is 0 and upper limit is 1. And what we are saying is this y is right, y by 2 is also in that range. See what is the range of y? 0 to 2.
0
right?
to 2, correct. Yeah.
So so y can vary between 0 and 2, correct?
Correct.
So can you take any value between this 0 and 2?
Let's take 1 for example.
Okay. If you take 1, then what will be that y by 2?
1 will
0.5. See, y is varying from 0 to 2, but that means y by 2 is varying from 0 to 1 only, right?
0 to 1 only, yeah.
So that y by 2 always will be between 0 and 1.
So the limits will always be of x.
Since we are finding the probability that x is lying between y by 2, so whatever value y can take, it will always be between 0 and 1, right?
So the range of x is what we implement in other words.
Yeah, correct.
Yeah.
Because that is a function of x only, right?
Yes,
so anyway, that should translate to that one. So that whatever y, the only thing is here changing is the range of y, right? And what we are doing it again, we are transforming it to that x to find the probability, like the CDF of y.
Yeah.
Okay. And here fx of x is 1 because we have taken the numbers here instead of a and b. So here 0 and 1 are there. So 1 upon 1 minus 0 is 1. So if you take a and b, so it will be 1 upon b minus a.
Yeah.
Right.
Thank you.
Yeah.
Sir, Just a quick clarification. Here, y is a function of y is a function of x, right? So we are finding the CDF of y, right? That's why we are taking probability of capital Y less than equal to small y. Okay. So why we are differentiating with respect to x? We could have differentiated with respect to y, right? Like while I'm finding the probability of CDF of x, then I'm differentiating my function with respect to x, right?
Differentiating or integrating?
Sorry, integrating. Sorry, integrating. So I'm integrating with respect to x, right? So here also we could have integrated with respect to y. Is it possible?
Yeah, correct. So you can do that, but you for that what you have to find, you have to know the PDF of y, right?
Yes.
Do we have a PDF of y?
No, we have PDF of x. No?
Okay, so that's why we are using PDF of x to find the CDF of y, and now we are going to find the PDF of y by using the CDF of y. So how can we actually go from CDF to PDF?
So just a follow-up question to that only. Since I'm having the PDF of x, so can't I take the help of PDF of x to find the PDF of y?
That's what we are doing, right?
No, PDF of x is given as 0, 1, right? It is given so PDF we can range is given 0 to 1, so we are finding the PDF as 1 by b minus c, right? So with that information, can't you find the PDF of y before integrating with respect to x? Isn't it possible? Isn't it possible to find the? I'm just asking. I don't have any answer, so I'm just asking. It might be a silly doubt, but I'm asking. Because while finding the CDF of x, we integrate the function of x with respect to x, right? So here I am interested to find the CDF of y. So can't I integrate the function of y like with respect to dy?
No, I understand your point, but the thing is, we okay. But it's actually, see, x is we know x, the PDF of x, right, which is 1 upon b minus a between a to b, right?
It would be and 0 otherwise.
And 0 otherwise. So what you are saying is, if I wanted to find the PDF of y, so which is nothing but, let's say PDF of y is
let us take y is 2x, right? Y is 2x. So my range of y is 0, 2a to 2b, right?
Okay.
Y is 2x, so it is 2a to 2b.
So now what we want to say is,
can't I do that y is the PDF of y is 1 by 2a minus 2a? Is it possible?
No. See, in this case, actually, okay, in this case, what's happening is, it's not directly possible because x was uniform, right? X was uniform random variable. Suppose, and here it is possible, I know, because here this is also going to be a uniform, y is also going to be uniform. But in case, let's say my function was y equals to e to the power x. Correct? If my function is like this, y equal to e to the power x, in that case, how can you find the function, the PDF of y directly? Okay, now can you tell me what should be the PDF of y here directly? Here it's okay. Here it's correct only because it's going to be the same. But here, can you tell me, is it going to is it going to become PDF of y directly by seeing 1 upon b minus a?
Here also it is not 1 by b minus a. We're just asking 1 by 2b minus 2a.
Where here, na?
Yeah.
Above. Here it is going to be, but the way to find it is, we have to find the CDF of y first. Okay, CDF of y, and then we have to go for PDF of y. And how we are going from CDF to PDF? By differentiating the CDF. And how to find CDF is, because CDF, we know the formula for CDF of y is, what is that? Probability that
capital Y less than equal to small.
Correct. So in that case, we can actually directly go from, so we can easily find the CDF of y.
Okay, sir. Thank you.
So again, this is okay. Let's see some other example. Maybe we can
1 second. The CDF has come as y by 2 in the previous problem, right?
Okay. Yeah. You
So
want to
how
find it ahead. Okay. Fine. Yeah. Sorry, I did not.
we want to find the PDF as well, isn't it?
Yeah. Okay. I thought. Okay. We have to finish it, right? So we know that what is the CDF of y? Capital F of y is. In our case, what happened here? It's 1 upon b minus a y minus 2. That was my CDF, right? When my x is uniform between a and b, right? This was the CDF, correct?
Yes.
Everyone is okay with this?
Yes.
Sir.
Uh-huh. So if you have doubt, then let me know here itself, so that okay. We have found out, right? This one.
Yes, sir.
Okay, I am not sure, like, or should I do it again? No, right?
No, sir.
Okay. Now, if I wanted to find the PDF of y, how can we find? We know that PDF of y is equals to d by dy of fy of y, right? So it is just a differentiation of the CDF.
Yes,
So
sir.
d upon dy of this CDF 1 upon b minus a into y by 2 minus a. So what should be the differentiation? It will, because since 1 upon b minus is constant, so 1 upon b minus is out.
1 by 2.
What is the differentiation of y by 2?
1 by 2.
It's 1 by 2. And what is the differentiation of a? Since a is a
0.
constant, it is 0. So my final answer should be 1 upon 2
B minus
bracket b minus a, which is nothing but, again, 1 upon 2b minus 2a. And so this is what? Is uniform, right?
Yes, sir.
So what is the distribution of y here? Distribution of y is uniform between
2a to 2b.
2 and 2.
2a, 2b, correct?
Yes.
So and if you put a equal to 0 here and b equals to 1, then what will be the CDF of x? Sorry, PDF of x? 1, right? 1. And in that case, what will be the range of y then again? Range of y? 0 to 2, right? 0 to 2, right? Since
Yes,
y
sir.
is equals to 2x,
Yes, sir.
then what will be my CDF? CDF of y. Just put b equals to 1 and a equals to 0.
Y by 2.
So fy of y is equals to 1 upon b minus a is 1 minus 0, y by 2 minus 0. So which is nothing but only y by 2, right? So that will be equals to y by 2. Okay, correct?
Yes.
Now, if this is become y by 2, now what is the PDF of y? Or what is the distribution of y?
Uniform
1 by 2.
0 to 2.
1 by 2.
So fy of y, so PDF of y will be equals to 1 by 2, right? And how can I write this PDF? So I can write fy of y equals to 1 upon 2, in which range? 0 to 2, right? And it is 0 otherwise. So how does this function looks like? Since this is a, this is b, so this is 1 upon 2 minus 0, which is nothing but 1 by 2. So this is looking like a uniform distribution. So y is uniform in 0 2. So this is the distribution of y. This is my PDF of y, this is my distribution of y, and this was my CDF of y. And when this will happen, when my x was uniform in 0 comma 1 and y was my function 2x, right? So all of are you silent? I don't understand you guys understood this or not.
Yes.
Yes,
Okay. Okay, now if you are understand, so let's take one another example. So x is uniform in 0 comma let's say 2. Okay, then find the distribution of y. Find the distribution of y when y is equal to let's say 3x. So tell me the steps. We'll go somewhat faster. Okay, first
And
of all
CDF
tell
of
me PDF of x.
1 by 2 minus 0.
2
Yes.
0 otherwise.
Yes.
Okay, right. Now tell me what is the range of y.
0
0
to
to
4.
6.
0 to
6.
6. 6.
0 to 6.
6.
Fine. Fine. Now tell me what is the CDF of y. So this is nothing but probability that y is less than equal to small y.
Yes, sir.
Now probability that y is what? 3x.
Yes.
3x is small than 3x is less than or equal to small y, which I can write it as x
Less
is
than equal to
equal to
y
y
by
by
3.
3.
Yes.
Okay.
Yes, sir.
Now from where to where I have to integrate?
0 to y by 3.
Yeah, since we are because this x is lies between 0 to 2, that means y by 3 we have to integrate from lower limit until y by 3, right?
Yes, sir.
Yes.
Find the CDF. So y by 3 here fx of x dx, right? Now what is fx of x?
1.
What is fx of x here?
1 by 2.
1 by 2.
1 by 2, right?
Yes, sir.
Yeah. So which is 1 by 2 here, and integration of
1 by 2
x.
X 0 to y by 3.
So this is turning out to be
y by 6.
y by
Y by
6.
6.
So this is what? Fy of y.
5.
So this is what? My
CDF.
CDF of y, right? So can you tell me what is PDF of y?
1 by 6.
Yes, sir.
So PDF of y will be
Differentiation.
so it is nothing but okay. So
1
if
by
I
6
wanted to
for
write in this
0
way,
to 0 to 6.
so this because it's d by dy of f of y, which is y by 6. So it will be 1 by 6, correct?
Yes.
So but within what range? Within which interval? 0 to
0 to 6.
0 to 6, and it is 0
Otherwise.
So what was that? This was my PDF of y, right? So what is the distribution of y now?
It's uniform in 0 to 6.
Uniform.
0 to 6.
0 to 6. Okay. Okay. Now,
Sir, sir,
hmm.
sir, can you take one more example, sir?
Yeah, I'm going to take one
Sir,
more, but somewhat difficult.
Yeah,
Sir,
difficult one, sir. Like
I'm
exponential or
telling,
trigonometry.
sir, x uniform between -3 to 2. Sir, uniform.
Uniform you wanted, or
Yes, sir.
should I use the other one? Okay, let's see.
Other one, sir.
Yes, sir. First uniform, x uniform -3 to 2. Y is equal to x square.
Let's say some other example. Let's say e to the power x.
Mod x. Modulus of x.
Modulus of x also we can take. So it's see.
Okay.
We can take the one more example, but now let's see. I wanted to check one more example with changing the distribution of x. Okay, so you guys have to tell me, and we are going somewhat faster. So first of all, what I wanted to find PDF of x. Okay, so what is PDF of x here?
1.5.
Everyone, lot of people I wanted the answer. What should be the correct answer?
1.5, otherwise
1 by 5.
1 by
Yes,
5, right?
Yes.
And 0 otherwise. Fine. Now tell me what is the range of y now?
e to the power minus 3
Power minus 3
to e square.
To find the value.
Yes, sir.
Okay. Now tell me what is the CDF of y?
Probability y less than equal to
Probability of
capital Y less than equal to small y.
yes, sir.
So which I can be I
E to
can
the
write
power
it like
x. E to the power x less than equal to y.
now.
X
We can
is
take
less than
log.
or equal to
We
ln
can
of
take
y.
log both side. Yes, sir.
Ln of
Yes,
log.
Is okay?
Yes, sir.
Now next. How to find this probability? Integrate from
Integrate from minus 3 to log y. And 1 by 5
1 by 5 dx.
Everyone understand, right? Because this is
Yes,
fx of x of dx. Now, so if you did here, then what should be the okay, now it's minus 3 to log y, 1 by 5 common, then
X.
1 dx. Okay,
So log y
it should be like
minus
1 by 5 here, x minus 3 to log y.
log y.
Log y plus 3 by 4.
Log y plus
plus
3.
3. Yes, sir.
So that will be what?
PDF. Oh, sorry, CDF.
PDF. Now what is
Yeah.
PDF?
We will differentiate this, sir.
Differentiate.
1 by 5.
1 upon 5 y.
Bracket no 1 by y plus 0.
1
Yes,
by
sir.
y plus 0.
Yeah.
Okay.
That means 1 by y, correct? So
Yes,
I
1
can
by
write 1
5
upon
y.
5y. Okay. Yeah. So 1 upon 5y. Okay. But I don't think we're going to go for any distribution of y, right? Are we able to find any distribution of y here? It's like in known form. This is anyway some distribution will be there. So I can write actually fy of y as what?
1 upon
1 upon
5y
5y between what range? E to the power minus 3
To e to power
e
minus
square.
square
E
and
square.
0 otherwise.
Yes.
Correct?
They're not able to tell into what the distribution.
Some we are not known distribution actually.
Yes, sir.
Like but it is some kind of distribution. Okay, one more question I wanted to tell you.
Sir, it just brings a doubt in the mind, sir. When we say find the distribution of x, right? Because the question wants to know about the probabilities of x, or it wants to know the shape of the distribution. What it
shape
wants to know.
shape of the distribution,
Shape of the
like
distribution.
uniform, exponential.
Okay, so
This
find the
when
distribution of x means we have to tell the shape of the distribution.
shape of the distribution, correct. So okay, in first lecture I think there are 3 properties sir has explained, right? But by using some that monotonic differential equation, that formula is there, right? So if you don't want to integrate, we can directly find some things. So what I wanted to do is, can we do it in a uh, by integration manner, so that if you don't remember that formula also, we can actually find that answer
from first principle.
Okay.
Yes,
Yeah.
sir.
So x is uniform between, let's say, 0 to 2 again. Now I wanted to find y equals to x plus 3. So what is this property?
Affine transformation.
Transformation, sir.
Affine
Yeah,
AX
okay,
plus B.
okay. Yeah, maybe
Transformation.
you can say translation, or you can say affine transform. Affine
And
also affine,
transformation.
because generally affine is ax plus b, right?
So A is 1. A is 1.
A is 1 here, yeah. So anything. So how to find the distribution of this y? So again, we can use the same things, right?
Yes,
Since we know the PDF of this is 1 upon 2 between, so this is PDF of x, right? Fx of x is 1 by 2 between
0 to 2.
0 to 2.
0 to 2.
Again, it's 0 otherwise. Okay. Now I wanted to find range. What is the range of y?
0 to 5.
No.
0 to 5.
0 to 5.
3 to 5, right?
3 to 5. Sorry, 3 to 5.
yes, sir.
yes.
3 to 5.
Yes. Fine. Is it correct?
Yes, sir. Yes, sir.
Now if the range is between 3 to 5. Now, I wanted to find the CDF of y. Is this correct?
Yes, sir.
Okay.
Yes, sir.
Now provided that x is less than or equal to
y minus 3.
y minus 3, right? Okay. So so in that I think equation, this step is directly given, right? The translation is there. We can use directly this formula, but it's okay. So for now we are not going to say anything about this. Now tell me how to find this.
Again, we will integrate
0
sir.
to 1.
Yeah,
0 to
y minus 3. 1 by 2
1 by 2 dx.
y minus
Sir,
Yes, sir.
this will be y minus 3 by 2.
2.
Right.
sir, I have a question here, sir.
Huh.
In for the limits of integration, why are we taking from 0 to minus 3 and not 3 to y minus 3?
0 to y minus 3, not 3 to y minus 3. So what is this equation tells us? This third line.
The value of x should be less. Adding up the probabilities where the value of x is less than y minus 3.
Yeah. So x is my x is going from where to where? 0 to 2. So I should so if I wanted to find, let's say some x is here. So how to find the CDF of this x?
So integrate from 0 to x.
0 to x, right? So
Yes,
this
sir.
x is nothing but, let's say, y by 3. Sorry, y minus 3. Now I have to integrate from
0 to y minus 3.
So that's why
Yes,
we are
sir.
integrating from 0 to y by 3, right? Okay. So this is my fy of y. Okay. Now can you tell me what is the PDF of y?
One by 2. Yeah.
Yes, sir.
Everybody understand this?
Yes, yes, sir.
Yeah.
No,
Okay.
sir.
No? Okay.
No.
So
3 to 5.
okay, this y minus 3, because how to find the PDF of y?
Differentiation of set
dy
here.
by dy of
Fy.
so it is y minus 3 by 2, right?
Yes.
So I can I write like this y minus 3 as let's say 1 by 2 is common, right? Can I write 1 by 2 outside and y minus 3 inside? So what is the differentiation of y?
1.
Huh?
1.
1. And what is the differentiation of 3?
Constant 0.
0. So this is
Okay, that's 1.
correct.
Thanks.
The complete presentation, sir, like in curly bracket.
Which one?
The complete presentation, like from this to this.
Yeah, that will do. So this is my PDF, right? Now I can write this PDF as 1 by 2 between 3 to 5 and 0 otherwise. So what kind of distribution is this? What is the distribution of y?
Uniform 3 to 5.
So everybody is okay with this statement?
Yes, sir.
Yes, sir.
This 3 to 5 came, sir.
Huh?
Use this one, sir, from 3 to 5, like range of y.
Huh.
Range of y 3 to 5. From there, okay, got it.
Got it, right? Okay.
Yeah, thank you.
So and okay. So if you wanted to use that affine transformation formula, how can we do that? So that affine transformation formula is nothing but so that it is said that if it is y is ax plus b, right? Y is ax plus b, then my fy of y is what? Or
1 by mod a.
fy of y. The PDF is given, right? PDF of is what? 1 upon mod a.
1 upon mod a fx of y minus b upon a.
Okay, maybe I'll write it's okay. Sorry, I should not write here, right? Sorry. I'll write, yeah. So suppose my y is equals to ax plus b. In that case, fy of y is equals to what?
1 by mod a.
1 upon mod a.
Fx of y minus.
1 upon mod a. Fx of
y minus b.
y minus b
upon a.
upon a, right? Okay. So can we check whatever it's given here, is it correct or not? So my y is what? Now in this case, it is x plus
X plus
3,
3.
right? So that means my a is equals to
1.
1 and b is equals to
3.
3. So my PDF can be 1 upon 1, correct? Fx of y is
minus 3.
y minus 3 upon 1. So fx of y minus 3. So is it correct or not?
Fx.
So what is fx actually? Fx of x. What is fx of x? Huh?
We'll have to integrate from 0 to x.
No.
No.
Here we know, right? Fx of
We
x
know.
is given here, right? See this.
Yes,
1 by 2.
1 by 2. So actually, what does this mean by actually? See, fx of x is 1 by 2. So if I put fx, what is fx of 1?
1 by 2.
1 by 2. What is fx of 2?
1 by 2.
What is fx of 1.5?
1 by 2.
So what is fx of y minus 3?
1 by 2.
1 by 2, right?
Hmm.
So what is the answer of this?
1 by 2.
1 by 2. So is it coming correct? Same?
Yeah.
Same, right?
Yes.
So you can actually use directly that formula, that affine transformation formula, or you can solve it by using whatever procedure we have done.
Yes, sir.
Okay. Is it understood to everyone?
Sir.
Yes, sir.
Okay. Okay. So
in lecture, professor is also using some inverse function and all, inverse formula.
Inverse, yes, sir.
That formula is there, right? So you can actually use that formula. So g dash of g inverse of y. But that is
only
only
applicable for
monotonic.
monotonic.
And differentiable.
Sir, how to check if a function is monotonic or not?
Yeah, I will tell you. So and into what is this? I think fx of
g inverse of
y. Right. So okay. Let's say my x is uniform between 0 and 1, and my y is equals to 2x. So is this a monotonic equation?
Yes, it's a monotonic.
Why?
How?
Continuously increasing the size. I put
Yeah.
one.
So let's say, okay, how can I write? So how can I draw this graph?
Yeah.
So y is varying from 0 to 1, right? And when my y is my x is 0, y is what?
0.
0. When my x is 1, my y is
2.
Half into
so yeah. So the slope of this line is actually
2.
2 times x, right? So
2
this
times
can
x.
be like this.
Straight line.
So this is the equation of line, right? So or this is the shape of that distribution. So what from here what we can see is this is continuously increasing, right? In that interval, that is important.
Okay.
Outside interval, what is happening doesn't matter, but in that interval, if that is increasing or decreasing, that is monotonic. So suppose the same thing is there. Let's say this is e to the power x. So what? How can we draw this graph e to the power x? So when x is equals to 0, y is equals to 1.
1.
Right? And when x is equals to 1,
0.71 something. 2.71.
2.7 something, right?
Yes.
So okay, I'll write in the different graph. This x, this y, and zero to 1. So x is varying from 0 to 1. That is support for x. Now y is varying from 1 to 2.71 something, right? So but you know that this is the exponential function. So if you put any value between 0 and 1, it will always increase, right? E to the power 0 is 1, e to the power 0.1 is some value, but
Some value.
it's more than 1, right?
Mm.
So if you put every value between 0 and 1, it will be the increasing only, right? It's going
Yes,
to
sir.
increase until
Until
2.7. So in this case 2.7, because we are just concerned about this range, right? 0 to 1. So here
Yes.
also it's increasing within that support.
So, sir, we have to check if a function is increasing or decreasing in the range specified.
In that
then
range.
we can say.
Yeah. So suppose some problems are there, right? Like this. What is happening here? So in that, let's say -1 to 1, some this formula is there, some function is there. So in this case, what is happening here? It is increasing between -1 to 0, and here it is decreasing between 0 to 1. So this is not monotonic.
No.
Understand? It's not monotonic now.
May I ask a question on this?
Can
I take it half of it, like -1 to 0, and consider it monotonic and do the evaluation, or it's not possible at all?
It is not possible that, because then this formula is not applicable actually. So if you wanted to do that, right, that integration is there.
Okay.
We are doing.
Okay, regular integration is what I have.
Is there? Yeah, that will see that regular integration whatever we are doing, right? That is applicable everywhere. This is some. So this formula is only applicable where you are having monotonic and differential equation.
Okay. The reason why I asked is in the adjacent diagram on the right, the range is from 0 to 1, and there is a box which is cutting off. So I was interpreting that as in the range, if it is monotonic, it is okay. That's the reason why I asked.
Yeah.
Excuse me, sir. Sir, can't we do it from -1 to 0? We can take this plus 0 to 1. We can again take this formula.
Yeah, that's what he is asked, right? So whatever you are doing, right, you are doing that integration thing, right, between -1 to 0 and plus 0 to 1. But then this formula directly is not applicable there. So you can actually directly use the integration formula there to find. We have that CDF formula, right? We can use that one between this range. Why it is not applicable? I'll tell you. Because see, this function is something different, right? So this might be some increasing function. Let's say I don't know what is the function of this, but it is directly proportional to -x here, right? And here it is y is directly proportional to x. So these two are different functions, right?
Yes, sir.
So if these two are different functions, then finding out this term here, it will be different, and here it is different. So it's not going to apply there. Okay, this formula is not going to give you the correct PDF there. So for finding out the PDF, you have to do the regular integration method.
But the second part is not directly proportional.
Invertedly.
It's directly proportional, right?
No, how come so? When no, my x is becoming 1, then y is becoming 0, right? It is not directly proportional.
Okay, is it like this? It's fine.
Yes, yes, right.
Okay.
No, sir, it's directly x plus y is equal to 1. So if you take y is equal to 1 minus x, then y is
okay. This is directly proportional. Yeah. So I think this function is y equal to 1 minus x.
Yes, sir. Yes, sir.
And
so it is y plus mod x equals to 1.
Some voice is coming from Abhishek. Yeah. So see, this function is y equal to 1 minus x. So y is anyway directly proportional to x here, right?
Please mute him now. Please mute him, sir.
So the function that you have drawn, I think it is y plus mod x equals to 1.
Which one? The total
The
one?
triangle, yeah. Y plus mod x equals to 1.
Here it is what?
Y plus mod x equals to 1.
That is 1 minus mod x.
Yeah.
Correct. That is true. So okay, shall we see some examples on this formula, or you will guys be able to do this question by using this formula? If you are able to find it by using this formula, then we can move to the next concept of expectation, or we'll see one more example of this, and then we'll move to the expectation mean variance. How you want to do?
Sir,
One example, sir.
Sir, before moving to expectation, can you also take one example from the previous concept, sir?
Which one?
Previous one, sir. From moving from
functions of random variable.
Yeah, yes, sir.
Okay, which one you wanted to tell me?
Sir, there is a question in activity question, sir. I can take from there, sir.
Please mute Abhishek, sir.
Yeah.
Which question number?
Yes, sir.
But you have to tell me now, okay?
Okay, sir. Scroll down, sir.
Question number?
Question number. Yeah, this one. This one, sir.
PDF of mod X. Okay. You have to tell me. Can you, Abhishek, one thing you can do is, if some background noise is coming from your side, like please ask them to stop or mute yourself for some time. Who asked me this question?
Yeah, me, sir.
Sridhar,
sir, yeah,
okay,
yes, sir.
Sir,
sir, and there is a x square in that, sir. One second, let me see. Minus 3 to 2, y is equal to x square.
I'm not able to. I have to. Somebody is actually doing this. Just a minute.
Yeah, mod x is fine, sir. Yeah.
Abhishek, can you mute yourself? Actually, so there is some background noise coming from your side.
Sir, you can mute all, right?
You can mute all. He is not in front of the screen, sir. Maybe.
Yeah, you can mute all, then we can unmute also.
One minute. Actually, my option of muting everyone is not coming here.
Oh.
Just a minute. I have to write in the. Wait. I'll ask me. Some problem is happening, I think. I'm not able to mute anyone actually.
Sir, Abhishek Kumar Singh.
Yeah.
Yeah.
Okay, so you are able to see my screen, right?
No, sir.
No, okay.
No, sir.
Okay, one minute. Which question? This question, right?
Yes, sir. Yes, sir. That
mod of x.
Yeah.
Mod of x. Okay.
Yes.
Just tell me. So x is uniform between what?
Minus 3 to 2. Y is equal to mod x.
Mod x, right? Tell me the usual thing what we are going through, right? So what is the PDF of x here is
1 by 5. 1 by 5 minus 3 to 2.
Right?
0. Yeah. Yes, sir.
Now what is the range of x? So range of y?
Range of y is 0 to 3.
What?
0 to 3.
Why?
Sir.
Mod of x, right?
Yeah. So if we take, sir, 0 to 3, because minus 3 to 0, the values, if we take mod, then it will be between 0 to 3. If we take minus 3 to 0, and if you take the value mod of that value, then 0 to 3.
0 to 3.
And 2 will be inside the
Correct.
interval.
Okay.
So that's why, sir.
1 meter. That Abhishek is creating problem. I don't know. I'm not able to.
One question on the range for y. If it is mod x, it should be -3 will become 3.
See, okay, how to solve this problem is suppose
There is so much disturbance, sir.
yeah, that I actually there I'm not able to.
Now he got muted, sir. Now he got muted. I think he's back on the screen.
He's not muted, right?
Yes, please continue, sir.
Okay. Generally, I will have that option, but today I'm not getting that option. Okay. Fine. So actually, okay. Can you tell me what is the graph of this?
Which one?
So y equal to mod x.
Yes, sir.
So since x is the range of x is from -3 to
2
plus 2, right? So when my x equals to -3, so what is the value of y?
3.
Plus 3, right?
Yeah.
So when is x equals to 3 also, my value of y is 3, right? When
Yes.
x equals to -2, when x equals to 1, so and until x equals to 0, so this will be like this, right?
Yes.
And when x equals to 0, sorry, when x equals to 1, y equals to 1. So my graph of y will be like this, right?
Yes, sir.
So this is my graph of y. So is it a continuous function? First of all,
Yes, sir. Continuous.
it's continuous, right? Right. Now,
I mean, sorry, it's not monotonic. That's what I meant. Sorry.
yeah, this is not
Function,
monotonic.
yes.
This is not monotonic.
Yeah.
So
It's
we are
continuous.
not. So this is not
Neither
monotonic.
differentiable.
So we are not able to find that G inverse of that formula. We are not going to apply. So we have to solve it by using the integration method only. So now
range is finally 0 to 3, right?
0 to 3, correct. C, right?
Yes, sir.
So since when my x is moving from -3 to 2, my y is going from 0 to 3. So that is my range here. Now, how can you find the CDF of y?
Again, fy of y is probability of larger y less than
So we
equal to
cannot
small
find
y.
it all at a whole. We have to
Mod
separate.
x less than equal to y.
So this is nothing but
minus y to y. Minus y less than equal to x less than x.
Okay, that is fine. It is the same only.
So both are same, sir. Minus y to y. Yes, sir.
Right? Now, yeah. Now, tell me how to find this one.
Sir, from here.
So we cannot do it at a one go. We have to do it in separately.
Between separate intervals, right?
So first, I am taking 0 to 2, the right hand part.
Okay, maybe we can go from here minus.
So you can do it separately, like first you consider that y lies between 0 to 2, then from that you can continue.
We'll go from like this, right?
Background noise.
Yeah, I know. I don't know. Nemade Amol is there, right? If you're able to come to know this. There is some problem. Shit. Okay, fine. Yeah, so -3 to 0, it will be what? Minus y, right? Actually, This can be done in this different way. This should be equal to you know this, right? F of b minus f of a. This formula also we can use directly, correct? Yeah. So this will be equal to f of y is equals to what? No, no. Okay. So what we can do is we can integrate this part and plus we can integrate between this part. Okay. So how can we do that? We have to integrate f of x from -3 to, so okay, this, what is the equation of this line? Y equal to -6, right? Okay, are you guys there? I'm audible, right? Hello? Hello?
You are audible only, sir.
Yes, sir, you are audible.
Yes, sir, you are audible.
Yes, some noise is there, something, I don't know. Okay. So what we can do here is, since we have to find the CDF of this, right? So 0 plus dx. Okay. So if you can do this, will that give us an answer? Someone has raised the hand, right? Yep. Vinayak and Sridhar is there. Hello.
कुठे जॉईन झाले?
Nemade Amol, can you mute yourself?
अच्छा. त्याचं बॅकग्राऊंड पूर्ण बॉलचं होतं, त्याने आधी बॉल कंपनीमध्ये काम केलं. ओके. किती वर्षाचा एक्सपिरियन्स आहे त्यांना? हा, इमर्सन आणि इमर्सन मध्ये ग्रोथ चांगली भेटेल. इमर्सन मधनं त्याला दुसरीकडे पण जम्पिंग इझी राहील. नको
Guys,
the
2 minutes, huh? 2 minutes. I'm just writing.
ते
Nemade
ते
Amol,
काही
can you
रिव्हिजन
just
यांचं सावर सुरू केले गॅस मूर्खांचं पाहून हा त्यांचं पाहून त्यांनी पण त्यांच्या लोकांसाठी अवर्स बेस सुरू केलंय ठराविक लोकांनाच आहे
okay. Okay. Yeah, sorry guys. Will this solve our problem or not? Can you tell me? So what can be the answer for this question? Yeah, can you guys now unmute yourself?
Yes, sir. Yes,
Okay,
sir.
okay, fine. Yeah. Sorry. So
Yes,
what
sir.
what happened here is,
Yes,
whatever
sir.
you are getting one here is what is actually the CDF of entire thing, right? So actually,
Sir.
so what we have to do here is we have to integrate bit from -3 to where?
Sir.
Y equal to -x, right? Yes, yes.
So what about this minus y to y, sir?
Yeah, correct. So
Here.
that's what I'm trying to say is, so what here? Okay, I'll just a bit of all this. So we have to find the probability between -y2 plus y, right?
Yes, sir.
So we can actually divide this thing into two parts. Now,
yes, sir.
Sir, can I say one thing,
First
sir?
you take.
Sir, sir has also explained this type of question, but in which this range has also come, sir. But I was not able to understand how you are solving the question. But I applied that concept and I got the answer for this right answer, sir. But
Okay.
I'm not able to understand the concept, sir. What he is doing there. I can do this by graph, sir. If we draw the graph of the uniform random variable and this graph, and if we take some y between the range, suppose.
See, okay. What I'm trying to tell you is, so this is our actually, see, this is our line, right? Here between -3 to 0, we have, if you wanted to integrate f of x of dx, so
Yes,
here x is varying between -3 to 0. That's okay, but how my y is varying here? Because we have to find probability that
x lies between
-y2 plus y. So we can actually segregate this into two terms, right? Or two different.
Yes, so you can divide into two parts.
Two parts.
Say y is first you take y between 0 and 2.
Okay, first is, let's say y is between 0 and 2. In that case, what will be the equation of how we have to find the probability is? Probability
Then probability y less than equals to small y, where y is less than equals between 0 and 2. So then x will be between 0 and y or between minus y and 0.
Sir, what if y is greater than 2?
It is 0, right?
Yeah, then we will have to take 0 to 2. We will not take y, sir, then. Minus 3 to 2 minus, sorry. Yeah, 0 to y in this part, sir. If y is greater than 2, then we will only take 0 to 2 because greater than 2 is 0.
No. We are integrating with respect to x, right? Here?
Yeah. Yeah, sir. But I am asking that this y value, sir, that is the range of the x only, minus y to y. If y is 2, then 0 to 2 will be there. Na? Are you able to understand me, sir?
I'm actually, I don't know, like you are saying 0 to 2. Why you are saying between 0 to 2?
Suppose, sir, y is greater than 2.
It is
so,
there, no? But y is, range of y is 0 to 3, right?
X is between minus y to y. Suppose y is 2. Then x is minus 2 to 2. And suppose y is 3. Then minus 3 to 3. Then we will only go from minus 3 to 2. Because greater than 2.
Yeah. Okay, that is okay. Yeah.
I'm
but
telling that.
we are integrating for x, right? That's yeah. That is okay. That is okay. So that's why we have to do between minus 3 to 0 and 0 to 2 separately, right?
Yes, sir.
So how to find? Let's say this take this only left side part.
Yes, sir.
First. So how to find that probability there? Or how to find the CDF there? So here, what is happening here? Probability that x, right?
Yes, sir.
Between when x is taking
minus 3 to minus y.
No, minus 3 to 0.
Minus 3 to 0. Sir.
Correct.
Sir, we go by the values of y, not by the x. So, take the values of y. Like in the range, you can segregate the range of y, not the x.
So how can you segregate the range of y?
Like from 0 to 3 is there, the range of y. Now, now the main problem is here. It is from the x is minus 3 to 2. So first I do it from minus 2 to 2. Then y is always 0 to 2. Then I can take 2 to 3 to get that portion, the which is not coming into minus 2 to 2 portion, because within minus 2 and 2, if the value of x is between minus 2 and 2, then y is between 0 and 2.
Correct. That is correct.
But that extra portion, that minus 2 to minus 3, that is 2 to 3, that I can do separately.
Okay, so you are trying to say is what we have to do here is, okay, let's try that one. But how over which portion you are going to integrate?
Yeah, so when y is between 0 and 2, then if I do probability of capital Y less than equals to small y, then it is becoming from minus small y to y x, because y is mod x. So it means that now from minus y to y, you can easily find the f of x, because f of x is given as uniform. So it is 2y by 5. This is when 0 to 2. And from the other half, where it is 2 to 3, then say when mod x, it is minus say y to plus y. But here y is between 2 and 3. The plus y will be greater than 2. So the upper limit will be 2, because x is less than 2 only. It cannot be y, because when it is more than 2, it will be 0.
Here this part is confusing, right?
No, because see, sir, when it is 2 to when y is between 2 and 3, then suppose say we are taking 2.5. Okay. So when mod x is less than 2.5, then x is between minus 2.5 and 2.5. So, but x is
Actually,
less than
so
equals to 2 always.
okay,
So
okay, I understand. But the thing
yeah,
is, that means we are not integrating between uh, uh, from for the range of y, right?
yeah,
So actually, see, we are integrating for fx of x dx, right? And this
yes,
minus y2 plus y is when x takes values minus y2
from
plus y, right?
yes,
But
yes,
that means within that range, when x is taking values between minus 2 to plus 2.
yes,
Now here between when x is taking values between minus 2 to plus sorry minus 3, it should be equal to what?
here like when I'm doing this, so minus y to 2, then you can do that f of x 1 by 5. Because when x is taking between minus 2 and minus 3, then y is always greater than 2, between 2 and 3, right? So
No, what should be the limit of this here?
minus y to 2, it's right. Yes, sir.
Minus 2 to minus y to 2, huh?
Yeah, minus y to 2, because minus y to y makes no sense, because y is always greater than 2. So it can take maximum up to 2. The upper limit is always 2. So it makes no sense.
He is taking value between sir minus 2 to minus 3. That's why he is doing this part.
Yeah, but still this is
Sir,
not.
I too am not able to understand this, sir. Sir has also used
Then
some.
this
So
way.
can I explain it from the beginning once?
No, okay, tell me, yeah. First of all, yeah. Tell me.
Okay, so you can go to a fresh page like here.
Okay.
Yeah, yes, sir. Sir, the starting the fx is 1 by 5 when x lies between minus 3 to minus 2,
Okay,
2.
that is fine. Yeah.
And 0 otherwise. So first I find the range of y, that is y equals to mod x. So it lies between 0 and 3.
Correct.
Yes. Now, as we are doing in the previous day, we first take the range of y as 0 to 2.
Okay.
Because there the function is like it's just a mirror image.
Correct. So this is for 0 to 2.
Yes.
Right?
Y is 0 to 2. So then probability y less than equals to small y becomes that probability of mod x less than equals to small y.
That is okay.
Then
Yeah.
minus y to y, that is the limit that you have taken over the integral. And the in between we have f of x dx.
Right. This is okay.
Yes. Next I am coming to when the second part, that is 2 to 3. Now f of y becomes probability of capital Y less than equals to small y. This is the same thing. Now say I am taking an example over here just to make understand that suppose y is say 2.5 small y. Then if I put mod x, it becomes probability minus 2.5 less than x less than 2.5.
Okay.
But I know that x is always less than 2. So it will be minus 2.5 less than x less than 2.
So x will always be between minus 2.5.
X less than 2. Now minus 2.5 is the value of y that I have taken. So it is basically probability minus y less than x less than 2.
So you are saying here it should be between minus y2 plus 2,
2.
right?
Yeah, f of x dx.
Okay.
Now normal, like I can do it.
Okay.
And what about minus 3 to 0, sir?
Where? From?
Minus 3 to 0.
Okay, so first place, what is happening here? I'll tell you first of all. So here, this was our f of x was, sorry, that y was here, right? So this was our function, correct?
Yes, sir.
This 2 and this is 0, this minus 3, and we have somewhere minus 2 here. So this portion, right, when minus 2 to plus 2 is there, then my y will vary from 0 to plus 2, correct?
Okay, okay. I got it, sir.
Okay, yeah. And when it is so when x is varying from minus 2 to minus 3, but
Yes,
we are not having this portion this side, right? So we have to just
yes,
consider only this portion. So in that case, my y varies between what? So between the 2 to 3, right?
yeah,
That
yes,
thing.
sir, yes, sir.
So my x actually should vary from so my upper limit of x should be 2, right? Only positive 2, because y is not having that value more than 2, right?
Yeah, yes, sir.
Sorry, x is not having that value, that's it, positive side. So here only just we are going from minus y to plus 2.
Sir, but we will have to draw the graph for this, sir, because
Yeah, without graph it is very difficult to understand actually.
yeah, yes, sir. But now I can clearly see, sir, why these two are sufficient. Yeah,
So then we can actually put up the values here, right? Same thing.
yes, sir,
Same
yes,
thing
sir.
we can do here.
Sir,
Hmm.
it will be better. We will hardly take 2 minutes. You can explain this concept from very beginning because there is so much turbulence during this problem. So
Okay.
can you explain from very
So
beginning?
yeah, I will do. But what we can do is, shall we move to some other
Yeah, sure, sure.
problems?
After
We'll do it later.
towards the end of the session, we can discuss
We can
because
discuss.
there
See,
is so much
because
background noise
yeah,
and so much. Everything is there.
we have lost like a lot of time in between, right?
Yes, sir.
So
Towards the end, sir. Okay, thank you, sir.
okay. So okay, this is about what functions we have done. So now we are going to do some expectation of a continuous random variable. So first of all, we'll see some expectations of only a random variable. Then we are going to see the expectation of expectation of a function of a random variable. Okay, so we'll take some similar simple problems again. So let's say x is okay. Shall we take somewhat okay? We'll take uniform only. Okay, fine. Uniform 0 1, right?
Take some other.
So what is the another thing? Okay, let's say exponential is fine, right? Exponential. So x is a random continuous random variable with this distribution, exponential distribution with parameter equal to 2. Now I wanted to find the expectation of x. Okay, okay, we know this one, right?
Yes, sir.
It is what? 1 upon
1
lambda,
upon
right?
lambda.
So it's 1 by 2. Now I have to find okay, let's say some x is my continuous random variable. You know that formula, right? So if x is my
Yes, sir.
Which form?
Yeah.
Expectation is equal to integration of x into fx dx.
Oh,
Your screen is not visible.
so you're not audible.
Screen is also not visible.
The screen is visible, but here lost the connection.
No, screen is not visible.
On the screen is visible but not audible.
Yes, yes. Visible.
Screen is visible.
Yes, screen is visible. Screen is visible. I think he has lost the connection.
Now it's not visible.
Yeah.
Screen is also not.
Can anyone tell when can we expect the result?
Answer key is released, you can check.
Yeah, answer key is released, but unable to recall the answers which I have marked.
Really?
So that is a problem.
Yeah.
When will the result come? Any rough idea?
I think so within some 3-4 days, I guess. I don't know.
I think usually it takes a week.
Yeah, within 1 week you can get.
Mhm.
Where we can find the key, ma'am?
In the mock test and quizzes, under that, you can just see that quiz.
Thank you.
Okay.
I think there is no pass or fail criteria in quiz, right?
Pardon me?
I think there is no pass or fail criteria in this quiz, right?
No, just whatever the marks you are going to get, that's what they will publish it. That's it.
Okay.
The quiz has 40 marks, I think.
Yeah. They are going to take 20% only for quiz 1. Right?
Yes, but you can do well in in programming test or.
Oh, no. I'm talking of stats 2 only. Sorry.
Okay. There's other one also. So there's some formula is there which will conclude the final result. Quiz one, some weightage of quiz one, some
Quiz
weightage
1
of
was
quiz
20%.
two, some max of 2 weightage, and the last one, the final exam is 60%. So there's some formula you look for.
I think for quiz 1 it was 20%, and quiz 2 it was some 30 or 35%.
I think some max they take some max of something, both the quiz.
But if you don't give one quiz, then you will lose marks. And if you give the second quiz, both the quizzes, maximum of that will be taken.
Yeah, like that.
Okay, hello guys. I was disconnected in between. So, okay, you guys still there, right? A lot of people.
Yes, sir. Yes, sir. We are there.
Yes, sir, we are here.
Yes, sir. Yes.
So, 1 minute. Again, they need to make me co-host. Okay. So, wait. So, you know that formula, right? I think before like I logged out, I think I was showing that formula. Expectation of x is integration between minus infinity to plus infinity x into f of x dx. That formula you guys know, right?
Expectation.
Okay. So if my random variable x is exponential one, okay, because we know expectation of x is 1 upon lambda from statistics 1 already. But if you don't know, then what you can do there? How can you find it?
Can't see the screen, sir.
Yeah, because
I'm not able to see the screen.
I know. Yeah, I know. See, because I'm logged out, so I'm not co-host now. They are making. I just send the message to the team. So just wait for 2 minutes. So what we are like, we can discuss, right? So tell me if I don't know the expectation of x is 1 upon lambda if my x is having a distribution of exponential function. So how can we find that expectation of x there?
Yes, sir. You can find integrating minus infinity to infinity x into e to the power
Lambda x into e to the power minus lambda x
dx. Yeah.
Lambda into e to the power.
Lambda x in x into lambda into e to the power minus lambda x dx. Integration 0 to infinity.
Correct. So if you integrate that thing, then you will get that.
Sir, minus infinity to infinity.
Yeah, but exponential x greater than equals to 0.
Yeah.
1 minute, I'm just again send the message to them. I don't know what to say. So, and suppose if okay, wait, they have made someone else. Okay, they made again same MA1004 as co-host. Okay, just wait. Okay, I'm able. I'll share my screen now. So now that was there. So if I wanted to find expectation of x, I'm going to find it? Minus infinity to plus infinity, x into. So what is the distribution of this expectation of 2e to the power
minus 2x.
right?
Yes, sir.
So x into 2 into e to the power minus 2x dx. But if my variable is exponential, from where to where I have to integrate? What will be the support of x, or what will be the range of x?
0 to infinity.
0 to
Yeah. So it will
Support
be
of x.
0 to infinity x into
2.
Right.
Hmm.
So that's, and if you solve this integration, you will get what? Expectation of x as 1 by 2. That should be have to get, right? So if you wanted to solve, you can solve it, or you wanted me to solve this equation. No, right?
So 1 by 2, it's
Okay. No, it's complete. So I don't know like how many people know this integration.
Yeah,
So you have to
complex. It
find
will be
way
complex.
u into v.
integration by parts. We
Yeah,
have to
integration by parts. So I'm not going to do that, but I just wanted to you guys to know that if you do this integration, you'll find this expectation. Okay. Now, if I'm having a function of a random variable, suppose y is equals to, let's say 2x. In that case, what will be my expectation of x? Or expectation of not x, expectation of y?
2 into
integration minus infinity to infinity.
So let's say, okay. So this 2x is nothing but g of x, right? So general formula for this is expectation of g of x is what? Integration from minus infinity to plus infinity.
G of x times
G of x times
fx of x.
fx of x dx. So now in this case, my g of x is y, which is 2x. Okay, and my y, the range of x is between 0 to infinity, right?
Yes.
So what will be the range of y or support of y? 0 to infinity again, right?
Yes.
Yes, sir.
Okay. Now, by using this formula, how can I write this expectation of y? This will be 2x into what will be my fx of x?
So we are taking exponential.
Yeah,
taking exponential.
Yeah, same.
Yeah, so that one.
So it will be 2 into e raised to power
e to the power
minus lambda. Sorry, minus 2x.
Yes, sir.
2 into
e to the power minus 2x.
So if you solve this equation, you'll get what? The expectation of 2x.
Y.
Or expectation of 2x or expectation of y. So again, this is the complex integration. So okay, what I'll do is I'll just, okay, all of you here are do you guys know this integration you will do? But okay, I am not supposed to do this integration, right?
You can just show something.
No, I can actually solve this integration, but the thing is, who are going to watch, it's a waste of time for them, right? I don't.
Why waste of time, sir?
Okay, I'll try to do it. So if my x
Please
is,
follow your flow, sir.
okay.
Please follow your flow, sir.
Okay, so if my x is exponential of 2, right? And if I wanted to find the expectation of x, which is nothing but 1 upon 2, so I need to find this answer. So I'm going to find by using the formula, which is x into fx of x, right, dx. So between 0 to infinity, x now into fx of x is, since x is a exponential distribution, so it should be 2 into e to the power minus 2x dx. Now you have to solve this integration by parts. So it is u into, so it generally u into what, okay, I will say u as x and v as e to the power minus 2x, because there is a rule called LIATE, right?
Liet.
So here it's L is logarithmic, I is inverse,
Inverse.
algebraic, trigonometric, and exponential one.
Exponential.
Okay. First of all, those who don't know these things, it's not like there is no problem if you don't know this also, because we are not going to ask these questions in the exam. Okay. Yeah. So I'm just solving this because some maybe some people here they knows this integration. So here what that means is you have to use that part first. So if it is logarithmic and inverse functions, two functions are there, so I'll take logarithmic first and I'll consider it as u, right, and inverse function as v. So here x is what, this is algebraic one, right?
Yes.
And e to the power minus 2x is exponential.
Exponential.
So that's why my u is x and v is e to the power minus 2x. And this 2 is constant, so I can take this 2s out of this integration. So how to, so this is the formula is u into integration v dx, right? So x into integration between 0 to infinity dx minus
0 to infinity x
0
dx.
to infinity x dx into
E raised to, no integration.
This is integration, right?
So ddx of x 1.
So u into v.
No, you. Oh no.
Sir, x should be there, sir.
No. Sorry.
It will terminate then.
It will be u into v dx minus
minus integration 0 to infinity 1 means a ddx of x.
du by dv, right? So it should be du by dx, right?
Yes, dx by dx.
Yes, so du.
So it
du
will be
by
1,
dx.
1 into
integration e to the power minus
to the
2x.
power minus 2x dx, right?
So it will be x.
But
by
do
1.
you integrate e power minus 2x again?
Yes.
Oh no.
Yes, we have to do that.
Yes,
Is it?
that is
So
not
the formula is u into integration v dv minus
v into integration du.
This formula is there, right?
Okay.
Miss, I am using this formula actually. So okay.
I think there are various forms of.
Yeah, two forms are there. So whatever you're using is different. Okay, but this will also give you the same answer. It's okay. So 2 into x into. So what is the integration of this?
E to the power minus 2x by minus 2 means minus 2 e raised to the power minus 2x. Minus
2. 0 to infinity minus. Okay, 1 minute. I just
minus 0 to infinity e to the power minus 2x by 2 dx.
Minus 2.
So that is indefinite. That is not definite.
2 here. So okay, x also has to go from 0 to infinity, right?
Yes, sir.
This is... I don't think we are going to use this one, right? Because if x is not having limits, we are doing some mistakes.
Something is wrong.
I think, yeah. See, we should not do. I think we should put the limits at the end or something. I think. Okay, maybe I forgot. Okay, so okay, one more. You guys have time, right, to do this? Otherwise, because we are just wasting our time today.
Sir, actually, there's another math session from 8 to 10.
Okay, fine. But this integration should be solved by using u into v dv rule only.
Mhm.
I think somewhere I'm also going to do. I'm making mistake there. Okay.
Sir, you take the limit at the last.
Yeah, limit. I think we have to take it last. I think, right, at the end.
Yes.
First of all, we have to solve this x into e to the power. So u into v. So let's see. It should be 2 outside. So it will be x into integration e to the power 2x dx, right, minus integration of I think it is like this, right? Missing something actually here. Okay, maybe I'll just try it later on. So I will try it and I'll share it this solution. Okay, because I think we are just like wasting the time here. I'm also not able to find it now.
Sir, it is integration of d by dx of x first we should do, sir. Then again integration e raised to power minus 2x dx. Earlier you were doing correct, sir, actually.
What?
Earlier you were doing correct, sir. First integration d by dx of x, sir, instead of e raised to minus 2x.
Sir, it is u times integration of v dx minus integration of differentiation
d
of
by
u
dx of u
into integration of v dx.
Yeah, du by dx.
Means it is a
Yeah.
Yeah, I was doing that only.
this only, but
so let's see.
Yes, sir. It is 1.
Sir, you are doing correctly, sir.
D
1
by
into
times
e to the power of minus 2x. Yes, sir. You'll
Yes.
get the answer if you do,
okay.
sir.
It was correct.
Let's try. But I'm actually worried about this x actually.
No, sir, it will not have problem.
Sir, it will become 0, sir. That part.
Okay, we'll see. X into
e to the power minus 2x by
2x by minus 2.
Minus here it's e to the power minus 2.
Minus 2x minus 2
again,
dx.
right? 2 into
2 into this you can leave it.
Just keep it like that only, sir. This.
Yeah. This
Yeah.
Will, we can't do there.
Minus e to the power of minus 2x by 4.
By 4.
Yeah, plus
minus
4.
2x
Yes,
by
sir.
4.
And it is again.
Now limits you can keep, so 0 to infinity. Yeah.
Right.
Now applying the limits, you will get 2 into 1 by 4, which
Yeah.
is equal to half.
2 into, so when it is infinity here, so it is 0.
Minus infinity
0
and
minus
0.
0 again, and here when I'll put 0 here, so this term will become 0, and this
By-
term will become
Sir, anything raised to power 0 is 1.
yes, 1.
So x by 2 minus x by 4. Sorry, minus 1 by 4.
Minus of 1 upon 4, right? Minus of minus 1 by 4, right?
So it is become 2 into 1 by 4, which is half.
Should I write it properly or okay? Here first integration when infinity is there, so it will be 0 minus 0 minus, when I'll put 0 here, so first part will become 0 minus this part will become 1 upon
4.
So if I'll do this, it will become 2 into
1 by 4.
So minus 1, so plus 1 by 4, right? Minus minus plus 1 by 4.
It's 1 by 2.
1 by 2. Yeah, okay. So yeah, so the limits we have to put at the last, and this formula will be like this, right? d minus integration du by dx or du to integration
v dv.
Yeah.
Yes.
Okay. Where I did mistake, I don't know. Did I do the mistake or?
No, earlier it was fine, but
No, sir, you were doing correctly only, sir.
Yeah, somewhere.
You got confused.
That limits.
Limit you have to put at last.
Okay, fine. Yeah. So we'll see some problems on expectation from our course here. Okay, because we have gone through that mathematical part, right? So where are these questions? Shall we check some other questions?
5.2, I guess.
So 5.2 expected time between the calls. Okay, this is again, we can directly use the formula, right? We are not going to see that one. Variance also we can actually find by using that x square into, okay, you know the formula for variance, right? If x is a continuous random variable, then what is the formula for variance? So you can do by this way also, or you can directly have the formula of variance of x as integration of x minus mu. So this mu is
E of x,
right? But most this is a preferable formula, right? To find
yes, sir.
expectation of x square into expectation
Easy
of x
also and prefer very quick.
Yeah. So if you wanted to
Also.
find expectation of x square, how can you find? So between these limits, so here it will be what, x square into
X square into fx of x dx.
And how to find expectation of x? You know this one, right?
Integration minus x times fx of x.
Okay. And if you find these two, you can easily able to find variance of x. You can find by this way also, but generally
General
this will
formulas.
become very complicated. Like you have
Very
to
much.
open that brackets, and again you'll get the same thing, but still. So you can use
Confusion.
directly this formula. Yeah. So we'll see one or two examples on this. Not the exponential ones, because exponential, because we are actually using the exact values from that exponential. Okay, shall we try this question? This one again. Okay, this is CDF one, right? Okay, we'll try to solve it. Yeah, seventh one. So it is given that f of x is, so PDF is given as how much? 20,000.
2,000, I think.
20,000.
20,000.
20,000
sorry.
by x cube, and x is
greater than 100.
Yeah. X cube and x is greater than 100. Right? And it is 0 otherwise. What you have to find is, you have to find
variance
expectation
of x.
So how to find the expectation of x? Since x is a continuous random variable, we know the formula. It should be minus. So this is generalized formula, okay? So it is from minus infinity to plus infinity x into fx of x dx. This is my formula. Now, okay, but my x is varies from where to where? We have to integrate only in that range, right?
Yes, sir.
So x is greater than 100. That
100.
means it is x is going
100
from
to
100
infinity.
to infinity. Now x will be here x, and what is fx of x?
2,000 by 20,000. Sorry,
by
x
x
cube
cube dx. Now this x and cube will get cancelled.
Okay.
Right. So, and this 20,000 is again constant, so it will be outside of
1
the
by
limit.
x square.
So, yeah. So do you know what is the integration of this? So if you don't know also, it will be provided in the exam. So so if you know, it is good. So it is 1 upon x square, right? So it is nothing but x to the power minus 2. So x, so this is minus 1 upon x.
Minus 1 by x.
Right. So 100 to infinity. Now, let's say, okay, I'm seeing, I'm taking this as a constant. So c into, so putting all the limits. So it will be minus 1 upon infinity, right? Minus 1 upon
plus
100. So this will become plus, because it's
minus
already minus 1, right? Now 1 upon infinity is what?
0.
So c into 0 plus
1 by
100. So what is the value of c? 20,000
sorry,
by
20,000. 200.
Okay. This is the value of expectation of
x.
So if you wanted to find the variance of x in this case, so how we are going to find? So
we will have to find
so for that, we know
e
that
of x square.
expectation of x square minus expectation of x to the whole square. So I know already expectation of x. Now I wanted to find expectation of x square. So I already told you it should be 0 100 to infinity x square into
20,000 by x cube.
20,000. So okay, for now we are seeing that 20,000 at c, some constant divided by x cube into dx. So x square and this will get cancelled. So it will be c outside 100 to
1 by
infinity
x
1 upon x dx. So what is the integration of 1 upon x? Okay,
minus
so again this is
x raised to the power minus 2 by 2 minus 2, sorry.
Huh?
X to the power minus 2
So it
upon
is x to
minus
the
2.
power of 0.
Yes.
No. Actually, okay. We are not going to say it should be actually log of x, right?
Acha, 1 by x. Okay, log of x. Okay.
Correct. Okay, so that's why that's why this question is not asked there, but I'm telling you. So
Yes, it is log of x.
Yeah, if you don't know this integration formula, it's okay. But the integration of 1 upon x is log x, right?
Yes, sir.
So okay, how to put the values? Okay, if you are okay, let's say you don't know the formula of it, but you know how to plug in the values, right? So if you have, because if you are given 1 upon x is log x, so how to put the values, you can just have to do. So it's c into
log of infinity.
Log of infinity. Okay, I don't know what is the value of this, and then log of 100.
100.
I think log of infinity is not defined. I think
not defined.
Right. Okay.
Yes, sir.
That's why we are not able to find the expectation of x square, and that's why we are not able to find the variance of x.
Variance of x square.
Okay.
Sorry, x.
That is okay, but that's why I think it is not asked in the question.
Just expected value.
So okay, we'll find the variance of x for this PDF. Okay. So fx of x is, what is this? 2 into
1 minus x.
X. What is the range?
Times. Okay,
0 to
1 minus x.
It is between 0 to 1, and it is 0 otherwise. Now
Yes.
We have to find variance of x. So we'll find it faster. Okay. So we'll
Yes.
move to the next thing. Okay. First of all, what we have to find is expectation of x. So I'm directly going to find between 0 to 1 x into 2 1 minus x dx, right?
Yes.
So this is 0 to 1 2x minus 2x
2x
square. So we can actually integrate separately. So okay, I will show you dx minus, since minus is there, I can integrate separately. 2x square dx. So it is 2 into x square by 2 from 0 to 1 minus, what is the integration of this? 2x
x cube by 3.
X cube by 3 between 0 to 1. Now this 2 get cancelled. This 1 only, right? 1 minus 0 minus 2 by 3 and 1 minus 0.
1 minus 0.
So it is 1 minus
2 by 3.
2 by 3, which is
1 by 3.
So that is my expectation of
x.
X. So, and what will be expectation of x square? Can I write the expectation of x square here itself?
Yes.
Okay. So I know expectation of x is 1 by 3.
3. Can increase the size of rubber. You can increase the size of rubber.
Okay. I don't know that option is there or not. This
Control plus.
Huh? External is Ubuntu. This is not the paint.
Okay.
I don't know. Maybe okay. Let's. Oh, this. Okay. But this is visible, right? This size is visible, right?
Yes, sir.
Okay. So this is what expectation of x square. If I wanted to find, this is x square into this f of x, right? So this becomes 2 x square minus 2 x cube. So I can actually do separate integration 2x square dx into 2x cube dx. So 2 is common. So what is the integration of x square?
X cube by 3.
X cube by 3 between 0 to 1 minus this 2 x to the power 4 upon
4 by 4.
Yeah, from 0 to 1.
1.
So it is 2 by 3,
1.
1 has 0,
Hmm.
minus, so 2 by 4 is 1 by 2, and 1 minus 0. So this is 2 by 3 minus
1 by 2.
So this value becomes 4 minus 3 is 1 by
1 by
6.
6.
Right. So if I wanted to find variance of x now, so this will be what? 1 by 6
1 by 6 minus 1 by 9.
1 by 3 square. Yeah. So this 1 by 6 minus 1 by 9. This
3 by
is
54, sir.
3 by 54.
3 by 54.
So how much it is?
3 by 54,
3
sir.
by 54.
Yeah, okay. 3 by 54, it's okay. But
1 by 18. 1 by 18.
Yeah.
1 by 18.
Okay, right. So that is my variance of x.
Okay.
Okay, this is kind of lengthy calculation, but I think that is doable, right?
Yes, sir.
Okay.
Yes, better than exponential function.
Exponential, it is kind of, yeah, that is difficult.
Very tricky.
Okay, so we'll see last. Okay, this is the last concept in this week. This is joint distribution.
So what is motivation?
Motivation, that is, you can see actually why we are going to see that joint distribution between discrete and continuous random variable.
Okay.
So how see why we are going for one discrete random variable and one continuous, the joint distribution between one discrete random variable and one continuous random variable. So
Okay.
sir has explained by using some one example. Yeah, one example that for
Iris
that
data. Iris data.
Yeah, that iris data is there. So iris data is yeah, that sepal length or sepal width is there. That is the continuous function, right? And there are 4 classes of irises. Iris is one type of flower actually. So there are 4 types of flowers are available. So that 4 times means what? 4 classes means 1, 2, 3, and 4, right? So that is a discrete random variable, right?
Okay.
So that iris class is a discrete random variable, and sepal length and sepal width is a continuous random variable. So by combining these two, so there are actually in real life, right? There are a lot of such kind of examples are there where we have to find we have to deal with one discrete random variable and one continuous random variable. So that is sir has given that motivation why we are going for joint distribution between discrete and a continuous random variable, or in case like multiple continuous random variables, right? So two continuous random variables are also there. So if you wanted to find the probability between the sepal length and sepal width, both are continuous random variables, right? So that kind of things are given there. So we are just going to see what is the joint distribution between discrete and continuous random variable. So
Yeah, before jumping into problems, sir, I have a conceptual doubt, sir.
Yeah, tell me.
Yeah, I think you are not going to discuss that, so I'm asking it upfrontly.
Oh, yeah. I'll tell you.
Even professor has also highlighted this point that many people are not able to understand this concept. So I'm one of them.
Okay.
Like, when we are taking continuous probability, conditional probability, so we are considering a particular value, right? But we know the probability of a continuous value at a particular value is always 0.
Okay.
So how here we are just taking an assumption. So how that assumption is valid? Of course, professor has said that you can just assume that it is not the probability at a particular value. It is just the probability in and around. Are you getting the point, sir? Say for example, here x is uniformly distributed, right? So it is discrete random variable.
Correct.
But my y is continuous random variable. So not in this question, but in some question, it will come that find out the value of x condition on y equal to 1 or y equal to 2, something like this. So my point is this, that probability of a continuous random variable is 0 at a particular value. Because it always takes a probability within a band, right? So how to digest this concept? Professor has said just simply assume that it is not the probability at a particular point, but it is the probability in and around that point, right? So I'm not able to understand that concept. So
okay, so I understand. Okay, so you are saying that since in this question itself, if you wanted to see
in this question is not there, can you solve it?
Yeah, okay, we'll see. So I understand your point. So that is marginal density, right? Actually,
yes,
y equals to 1.
yes, that is marginal density.
So if y is my continuous random variable, and if I wanted to find fy of 1.
Yes, so how is it possible? Because fy1 will be 0, because my continuous, just in last week itself, we learned that the probability of a continuous random variable at a particular point is always zero.
Correct.
Like here you can see y equal to 1 and all.
Fy of 1. You're saying, right?
Right.
Okay.
Yes.
But
Yes.
here this fy of 1, right? Correct.
Not here. When it is conditioned, when my
okay,
random variable is conditioned on my continuous probability, continuous random variable. So many times same words are getting repeated. So when my discrete random variable is getting conditioned on, yes, you can take this one.
So x is Bernoulli random. Okay, I understand your point. So you're saying x is my Bernoulli random variable, which is a discrete random variable, right? Y given x equals to 0 is a exponential random variable, which is a continuous random variable.
Correct.
Similarly, y given x equals to 1 is a normal random variable, right? So now if I wanted to find a probability that x equals to 0, given that y equals to -1. Correct?
Correct.
But so in this case, what will happen? You will have the joint density in the numerator, right? Probability that x equals to 0, comma y equals to -1, where we can find by using that another formula, that another conditional density. So probability that y equals to -1 given that x equals to 0 into probability that x equals to 0, right? In the numerator. Okay, maybe I'll write it. Maybe. So here x is Bernoulli 0.5, right? And can you tell me the why is this distribution?
First one is, I think, exponentially distributed with lambda 2. The second one,
It's normal, I think, right?
Yes.
It's normal 0, 1.
0, 1, yes.
Okay. Now, x is Bernoulli, y given x. So this is the conditional density, right? But this is having a this distribution, right? This is having this distribution. This is which are the continuous distribution. So given that your discrete random variable, you are having that y is having a continuous distribution. And now what we have to find is this one. What is that x equals to 0 given that y equals to -1. How can we write this? So okay, generally how can we write the conditional density here? So it will be like this.
Marginal divided by, intersection divided by marginal.
So this intersection or joint density, how can we write? Because so I can write like this way, right? Probability that y equals to -1 given that x equals to 0, which I can write like this also, I think. Provided that y given x equals to 0 of
using base law,
-1.
using base law. So now we will multiply by fx0, yes.
Right. Divided by probability that y equals to -1.
Yes. So now here my question comes that now it should be 0.
This one you're saying, right?
Yeah, should be 0.
Okay. No. Just wait here. So this y, is it a discrete random variable or continuous random variable?
It's a continuous random variable.
How do you know?
It's given in the question that y is continuously distributed. Even if it is not given in the question, then there are other cases which professor has discussed where y is completely defined as a continuous random variable. Very clearly it was defined that y is continuous random variable. If you go to the lecture, then it is very clearly defined that y is continuously distributed. It's a continuous random variable. So what explanation professor has said that?
Okay, I don't know. So which in this lecture he is saying, huh?
Yeah, in this lecture.
Okay, I'll see that lecture again and I'll tell you what.
So that's why we always request that one session should be for concept clarification.
Okay, that is okay. But the thing is, we're not actually watching the lectures.
No, why not, sir?
Again and again.
I have watched. That's why I'm saying.
No, I know. See, the thing is, yeah, I understand. So I will try to explain it to you.
That's why I'm putting the question up front. Without watching the question, I will not. Without watching
no. What I'm saying. Listen to me. So what I'm saying is, we are not watching that lectures regularly, because we are teaching it for like 2-3 terms, right? So we have already watched once, so we are not watching. So whenever you are saying in this lecture this point is there, it's like It's not immediate for us to okay.
I
Sir
can
has said like
understand,
this.
sir. I can
So
understand, sir. But
yeah,
but,
I can.
but very politely, I would like to say that so directly solving the activity question is not solving people like me, because by now all
Okay.
activity question must have by
Correct, correct.
hearted for you people. You
Correct,
will
correct.
see the question, I will solve it, but it will not help people like me, a slow
Yeah.
learner.
No, I understand. So it's not like I'm not going to tell you what is there, but I'm not right now. What I'm saying is this is not for me directly. I will tell you whatever you're saying is that same context sir has said, right? You're understanding my point. So you are saying me this
Let us
sir is saying
continue.
that.
Let us continue, sir. Please.
No, that what your point is, because since this is a continuous random variable you are saying, and provided that y equals to -1, it should be equal to 0. You are saying, right?
Yes.
Because it is taught in the previous lectures in the continuous random variable that uh, if a, if my random variable is continuous and if CDF is given, right? In CDF is my continuous random variable only, right? Or CDF is a continuous function, right? In that CDF, yeah, in that CDF, what we are saying is finding the probability at this particular point is equal to 0, because we are in already in CDF what we are finding is provided that x is less than or equal to x. This is the uh, formula for CDF, right? We can't able to find fy of x, right, at that particular point, or fy of x equals to small x, correct, is equal to 0, right now.
Yes, sir. Yes.
So your point here is why can't this provided that y equal to -1 is not equal to 0, right? Why this is why we are going to find this fy of -1 or something? How can we find that fy of 1, right? That is your point, right? Or something else is there?
No, yes, sir. You got my point, sir. Thank you for that.
But what is this provided that y equals to -1 is what?
No,
What do you
now we
understand?
can now we can calculate it with the help of Bayes theorem. We'll find the marginal probability of y. We'll find the complete probability of y, and then we'll compute y equal to -1, and we'll get that probability, and we'll solve it. So solving this problem is not a problem. Conceptual understanding, I'm looking for that. I know that you will find the total probability of y, right? Y random variable.
Okay.
And then one part you will take what is the marginal probability of y at -1, and it will plug that value here, and we'll get the answer.
Okay. So your question is regarding this, why this is not equal to 0?
Yes.
It should be equal to 0. That is your question. But this is not actually one thing is what now what I am understanding is this is not a CDF, right? First of all, so if even if it is a continuous function or a continuous random variable also, I know the finding the probability at certain point is not possible. But why this is 0, right? Okay, I understand your point. I'll try to give the answer to you right now. Also, I am also not having, because I am also solving that question only.
Yes, no problem, sir. We can continue with
yeah,
that.
I will but yeah, I will remember this question and I will
We
try
can
to
continue
explain
with that.
someone.
Yes,
Yeah.
we can continue.
Okay. Fine. So okay. Yeah. Others are there or left? Okay. Only 23 people are there. Huh? Okay. Fine. So okay.
We will be there, sir.
Maths to session has started, sir. Maths to session has started. So
okay.
maybe...
Okay. So you guys, where we are before this discussion happened? So
Yes,
yeah,
one
is okay. One is so when we are having one discrete random variable and one we are one is a continuous random variable. In that case, how to find the joint distribution? That was our question, right? Or how to find the marginal distribution also, and how maybe how to find the joint distribution. So here in this question we have x uniform between 1, 2 and 3, and let y given x equals to 1 is a distribution, is having a distribution of exponential with parameter lambda equals to 1, and y given x equals to 2 is also exponential with parameter 2, and similarly this thing is there. So find, this is the question is find the distribution of y. So how to find the distribution of y here? Okay, please tell me the question here. So x is uniform between 1 comma 2 comma 3, right? And y given x equals to 1 is having distribution exponential 1, y given x equals to 2 exponential 2, and y given exponential x equals to 3. What third one is what? Exponential 3. Okay. So we have to find the distribution of y. So how to find the distribution of y? So what do you want to find here is the fy of y, right? PDF of y, correct? So we know that formula is there. So it is nothing but summation of x into, sorry, right? Is this correct? Okay. Have you watched this lecture or not? Okay, if you don't if
That is
you
fourth
didn't
week,
watch
sir.
the
Yes, we
lecture,
watched it.
so this is the formula, right? This is the formula to find the distribution of y. So what is this? This is PMF of x, right? And this is the density of y given x. So we have to just multiply these two, and we'll get the distribution of y. So x is varies from 1. So x is taking values 1, 2, and 3, right? And since it is uniform in this range, so what is the probability associated with it? So what is the PMF of x is here? It's 1 by 3, right?
1 by 3.
For each value of one, which value taken by x, right? So when px of 1 is there, then it is 1 by 3. Sorry, px of 1 is there, then it is 1 by 3, right? Probability of x taking value 1 is 1 by 3. And when x is equals to 1, and what is the distribution of y then? It is exponential of 1, right? So that probability, how can we write? 1 e to the power minus x, correct? Similarly, when x takes value as 2, it will be equal to 1 by 3 into 2 e to the power minus 2 plus 1 by 3 into 3 e to the power minus 3. So this should be the distribution of y. If you simplify it, it will become 1 by 3 e to the power minus x plus 2 into e to the power, okay, here it's 2x, right? Oh no. It's 2, okay. Yeah, 2 only, right? Not x. Because x is equals to 1 now, we have already said. So it will be 1 minus e to the power minus 1 e to the power minus 2 plus 3 e to the power minus 3. So that should be my distribution of y, correct? So I think that some option 4th. Okay. Yeah, y should be there, no? This is not x. So, yeah. So option D will be the correct option, right? So similar, actually, everywhere is similar concepts is used to solve these questions. Apart from that, okay, for this kind of questions, if y is a function of x and z, where x is a uniform random variable and z is a normal random variable. So here y is a function of a discrete and a continuous random variable, and x and z are independent. In that case, if you wanted to find the distribution of y given x equals to 1 or y given x equals to 1 minus 1, then how can you find the distribution? Okay, anyone is here or
We are always there for you, sir.
Yes, sir. We are here,
no,
sir. Don't worry.
nobody is saying something, so I don't know, like You wanted me to solve this or not? I don't understand.
Today only at the start we discuss. Na, we should not disturb the session. So we are,
Okay.
we are listening very
Okay.
attentively.
So my y is a function of a discrete random variable and continuous random variable. So x is what? X is which distribution? Uniform between -1, 0 and 1. Okay. So this is a discrete random variable, right? And we can easily find it out by using, because this curly brackets are there, that means it's a discrete random variable, and z is a normal random variable with parameters 1 and 2. So 1 is what? Mean, and 2 is sigma square, right? So this is a multiplication of these two, and it is said that both are independent. Okay. Now we have to find, so among those four options we have to find which options are correct. So I think one option is given, y given x equals to -1, I think, and another is given y equals to +1. And let's say we'll try to find at the end y equals to y distribution of y given that x equals to 0. Now if you wanted to find y given x equals to -1, so what kind of distribution it will have? How to find this distribution? Since y is a function of x and z, so what is the distribution of y will have when x is equals to -1? How to find that? Any idea? Okay, now you can talk. Actually, I'm asking you guys.
You have to find the joint distribution of y, sir, right?
Huh? Distribution. We have to find this distribution.
Yes, that is the conditional
Conditional distribution.
Conditional distribution, right? So before that, we have to find the distribution of y, like how y is, because y is jointly distributed, right? That we have to find out.
But by looking at
like for discrete, we used to take, we used to plug both values of x and z, and we used to find the range of y, right?
Okay.
For discrete,
So you wanted to, you said, you are saying that we have to find first of all f of y, huh?
Yes.
So, but how to find an f of y here? Okay, I will tell you that I can directly find the distribution of y here, but okay, we'll do that later. First of all, tell me how to find f of y here. It should be, since y is not it's this function, right? X into z.
Yes.
So this is a multiplication of one
discrete, one continuous.
continuous. Then in that case, how to find the distribution of y? So if you wanted to approach this problem, how will you find it?
Probability of x and then marginals of z. So like -1, and then
okay.
One is, so for -1, the probability will be 1/3, right?
Correct. Yeah.
The probability of x will be 1/3 for all the three values, right? And then we have to find out the marginals of g.
So how will you find that? Let's say, because see, when my okay, in the previous problem what happened was, if you remember this problem, x was uniform between 1, 2 and 3, and this distribution is given. In that case, we know how to find the distribution of y. That was f of y. How we find out? We have found out that y given x equals to 1 into probability of x, right?
Okay, sir. No, what I'm trying to say, sir, we have to use that probability density function of normal distribution, that is 1 by sigma square root 2 pi e to the power minus x minus e to the whole square by 2 sigma square.
Okay. Okay.
Sorry, by sigma square.
Okay, we'll do that. Yeah. So it will be 1 upon sigma here is root 2, right?
Yes.
So it will be 4 pi.
Root of 4 pi. E to the power minus.
E to the power minus.
X minus mu.
Okay, here is z, right?
Here it is y. Here is z, right? So z x minus mu is 1 the whole square divided by sigma square. So it is 2.
2 sigma square, right? 2 sigma.
Yeah, it's 2 sigma square, right?
It's 4.
Similarly, we'll do for other value also, for 0 also. So 1 by 3, and then again we'll compute the same value. I think so 1 by 3, and then 1 by, like this. I think we'll compute.
Then it will directly become 3 times
Yes,
1 by 3, no?
Correct.
Huh?
Yes, sir.
But then okay, 3 get cancelled, so this will become my equation.
But the mu value will keep changing, na, sir? Sorry. Yeah, it will become this. Yes.
Then is this a distribution of y, or it's a distribution of z?
In that case, it will become the distribution of z. In that case, it will become the distribution of z.
Then how to find the distribution of y? So can we do here one thing? So since y is a y equals to x into z, right?
Correct.
Okay. So if I'll put value of x here in this formula, so what it will become? Since we know that given that x is equals to -1, that means I know what is the value of x.
Equal to -1. -1.
Actually, whatever you said right here,
yes.
it is almost like similar what I'm trying to say.
Yes.
But let's say given that so okay, we'll try to write it this formula. How can I write this? Provided that y
intersection probability, yes, divided by marginal probability of x equal to -1. Yes.
Okay, right. So in that case, what will be this probability, the numerator one?
Sir, can we take the help of base theorem and we can reverse that, like p equal to x?
Yeah, we can actually take that one also.
Yes.
So, but in this case, can we do like similarly what we are doing for? Okay, let's see. We'll try to do that also. So what here you have to do is x equals to -1, right?
But I suppose that will not.
But this won't help, right?
This won't help because we don't have values. We don't have value to plug in.
This is condition.
So just try to see what is this saying. It's conditional given, right? So already it's given that x equals to -1, and
yes.
If I plug in the value of -1 here, so y will become what? -z. See, my y is equals to xz, right? So if my y is equals to xz, given that x equals to -1, this will become y equals to -z.
Right, sir.
Yes.
Correct. And what is the distribution of z here? It's normal.
Yes.
1, 2. So -z means it is what? That is scaling property, right?
Yes, sir. We put a minus sign before.
Is it a scaling property? So whatever we have studied, right, in the continuous and today, so we studied about that affine properties, right? So ax plus b. So if you have this only ax, so that is your what? Scaling property, right? So in that scaling property, what will happen? If my normal 1, 2 is there, so will there be a change in mu?
Mu will not be changing, sir.
Mu won't change, right? Or it will change? Tell me.
Mu is nothing but a mean, so it will not change.
So let's say y is equals to ax. Huh? And what is mu is? Mu is expectation of y, right? So this is expectation of ax. So it is a times expectation of x. So
yes,
mu will change or not? It will change or not?
It is changing.
It should change, right?
Yes, it is changing.
Yeah.
It is getting multiplied by a.
Yeah. So my mu is here is 1. So if -z is there, then my mu will become what?
-1.
-1, right? normal minus 1. Now what happens to my variance? So variance of
I think variance doesn't
y
change.
is equals to a square into variance of x, right?
Yes.
Our first properties are like this. So a square is minus 1 square
So that will
times
not
variance
change.
of x. So this is 1. So variance is not changing. So variance is becoming only 2. So that will be my distribution of what?
Y.
Y, right?
Y. Yeah.
Y. So my distribution of y is become normal minus 1 comma
Now
2.
we can use that formula 1 by 2 pi.
Now we can use our regular formula 1 upon sigma root 2 pi
square root 2.
e to the power minus y minus mu square divided by 2 sigma square.
Yes.
Now similarly, tell me what will be distribution y given x equals to 1.
It is the same concept, so then it will be G only.
Here then what will happen? My expectation will change or not. So y equals to z now,
Yeah,
right?
again
So
it
y
is
equals to
same.
z means what? It's same.
Yes, yes, same.
Nothing should change, right?
1, 2, yes.
Okay. These two is there in the options. Let's try for solving the last one. I also don't know the answer, but we'll try. So y equals to y given x equals to 0. In this case, what will happen?
Y should become 0.
So is there any distribution there? No. Right?
No.
So y will have y had two distributions, right? So not y will have. Actually, this is conditional distributions we got.
Conditional random variable.
Yeah. Now if you know, now this we know that y given we know that y given x equals to minus 1, and we know y given x equals to 1. Now can we find the distribution y? Now we are able to find, right?
We'll
You
add
are
both of
understanding?
them.
Yes, sir.
We'll add both of them.
Yes. Now, but how will add? It's not like this. We have to add like this, right?
Yeah, conditional with merge.
Correct. So here how will add? It should be 1 by 3 into this one, which is normal minus 1 comma 2 plus 1 by 3 into 0, right? Plus 1 by 3 into normal 1 comma 2. Is it making sense now? Or okay, maybe I'll summarize it again. Okay, so x was uniform between minus 1 0 1, right? And I know that y is a function of x and z, and z also having the distribution like this 1 comma 2. So if I wanted to find the distribution of y, how I'm going to find the distribution of y here? I have to find, because directly we tried, right? We tried, but we were not able to find that. So there is one thing is, we can actually find the conditional distribution of y, and then we'll proceed for the distribution of y. For that, when my x, so I'll try to find here only three conditional distributions are possible, right? Conditional densities are possible. So y given x equals to minus 1. So how I find it, this value? I just plug in this minus 1 here in this equation, right? So this will become what? This distribution will become normal minus 1 comma 2, right? Then I found probability that y given x equals to 0, which is 0 actually. Then probability that y given x equals to 1 is normal
1, 2.
1 comma 2. Now if I wanted to find distribution of y, I can find using my formula. So PMF of when x takes value minus 1, the probability is 1 by 3. Then y give when, okay, so this should be equal to like this, right? Px of minus 1 into fy of, right?
Yes,
So this is this probability, which is normal minus 1 comma 2. So shall I, okay, I'll write like this only. I'm not going to write the formula. Plus 1 by 3 into 0 plus 1 by 3 into this
n1,
distribution.
2, n1, comma 2.
Correct. So this should be my distribution of y. Now you understood, right, how to find this? Okay, suppose same problem is there, uniform -1 0 comma 1, and my function is like this. Then what will happen? How I'll approach this problem then?
Using the same method, but y will still be a function of that -1 comma minus z.
So if my x equals to -1 is there, then y equals to what?
-1
minus z plus
Minus z minus 1.
Yes, yes.
So this will become, and z is what? Normal 1 comma 2.
1 comma 2.
Then this distribution will become, so this is a affine transformation,
Yes,
right?
1 plus z.
So
Yes.
this will become what? -2, correct? Comma. Is it?
From this -2 is coming, sir?
Okay, expectation of y is what? Expectation of y is here is what? Expectation of minus z minus expectation of -1, right? So this is minus expectation of z, right? And -1 because it's constant. Expectation of a constant is -1. So what is the expectation of z?
-1. -1, -2, yes.
Right. And similarly, if I wanted to find variance of y, how can I find? So it should be variance of minus z and minus variance of 1. But variance of any constant is 0. So this should be equal to variance of minus z. And I know from the property it's -1 square into variance of z. So
So
this
that
variance
formula
of,
we can use only when these are independent, right? Suppose these, so I suppose both of them are independent, right? Okay, then only we can use that formula.
yeah. So it's already okay. Same problem is there. I'm just
Okay,
so
okay,
both
got
are
it.
independent. Yeah, that is important. Otherwise, it's not possible. Yeah, correct. Now this should be the distribution, right? Same. Now you can use for like same, right? When x equals to 0. So if x equals to 0, then
That will be 0.
okay, this time will it become 0 or not?
So that will be 0.
It will become 0, correct. Then y given x equals to 1?
Here it will become 2 comma 2.
Okay, and now we can easily find the distribution of y. Okay, so I think this thing is only important, I think, and otherwise you can solve the problems. Okay, regarding that question you asked me, right? I will go again and watch that lecture, and I will try to clarify on that in the next lecture. Okay, that question is there, and which any other question is there I need to clarify? This one is there, and I know another, I think 2 questions are there, right?
Sir, can you explain me please this y conditioned x is 1 is normal 2 comma 2 how it has come please?
Yeah. Okay. So let's say this conditional probability is there, right? And y is what? Y is a function of x and z, correct?
Yes, sir.
Now, if I wanted to say y given x equals to -1,
okay, sir.
What is the meaning of this conditional density, like conditional probability that given that x equals to -1, right?
Okay, sir.
What is the value of y
Uh-huh.
in other terms?
Yeah,
So
it
if
is minus z minus 1.
so y will becomes what?
Yeah.
This should become, right?
Yes, sir.
Because I know already x is taking value -1. So
Yeah.
the distribution should be looking like this.
Okay,
-z
sir.
-1. So and I know from this is another this is affine property, right? And I know the distribution of z, right?
1 to 2.
That is normal 1 to 2. So what will happen for the distribution of y now? So this is not actually distribution of y, is y given x equals to -1, because I already said that. So this is the distribution of y given x equals to -1, not the y. But so what will happen? You know the affine properties, right? Affine
Yeah,
transformation.
ax plus b.
So if ax plus is there, then what happens to that distribution? So your mu, right? The mean will change with how much? You don't understand this.
No, sir, that part I'm not
Okay.
understanding. Can you help me?
So actually you can actually find the distribution itself, but I'll try to say. So suppose on number line, right? Okay, I don't know how to explain it. So, you know
Just
translation
shift
property.
it, sir. Just
Yeah,
shift it.
yeah,
That's
that
all.
shifting. But you first of all, you know the translation property. How we are shifting it? Okay, okay, fine. So it's actually. Are you there? Who asked me this? I'm sorry, I don't know. I don't.
Yes, sir, I'm there, sir.
Yeah. So see, I want to. So what is this normal distribution? This is what? Mu, right? Expectation of.
Yeah, mu, and that
Z.
is variance. Yeah.
Expectation of z and variance of z, right?
Yes, sir.
Now I know that the probability. So I know that y given x equals 2 minus 1 is following this distribution,
Yes, sir.
right? Now if I wanted to find the expectation of this distribution, this distribution, conditional distribution, I can easily find out by using this, right? Generally, if you wanted to find the
Yes,
function
sir.
of expectation of function, right? Like this, you can find. Correct?
Yes, sir. Yes. Yes, sir. This
Okay.
I understood.
Okay. Now expectation of minus z. So by using the property, it is expectation of z minus expectation of 1.
Yes, sir.
So what is the expectation of 1 actually?
Yes. Zero. That is a
1.
constant.
No, 1, 1.
Oh,
See,
one
if
is
you have.
one. Yeah. Yeah, yeah. I could not hear. Yes, sir.
Okay, expectation of 1 is 1, right? Okay.
Yes, sir.
Now, what is expectation of z?
It is z.
This one, right? 1.
Yes, sir.
So I can
1.
replace here. It's 1, right?
Okay. Okay,
And
sir.
1. So this is what is this minus 2? Actually, this is the expectation of this.
Yes, sir. Okay, sir.
And what is this distribution? What is the distribution of this thing? Actually, this is normal only, right?
Yes, sir.
So this is minus 2, and variance also you can actually check by this way. So if you wanted to find the variance of this distribution, you just go for this thing.
Okay.
So variance of the constant is 0, right?
Yes, sir.
And variance of minus z is what?
Expectation of minus z whole square minus expectation of minus z square. Correct, no, sir?
Or else we can say by using other property, it should be so variance
minus
of
variance z.
X is a
A square
into,
times variance x. Yeah.
So here it is minus
variance z.
So minus 1 square
into variance z.
of z.
Yeah.
So 1
variance
minus
z.
1 square is 1.
Yes,
so into
sir.
variance of z. So variance of z is what? 2.
Yes,
so
sir.
variance of this distribution is also 2. See,
Okay, sir.
I'm not deriving this
Understood, sir.
properties. Okay, I'm just telling you
Okay,
by
sir.
this way, but you can
Yeah, I
actually
understood,
find
sir.
using.
Yeah,
So
yeah.
this distribution you can find by derivation also. But okay.
Okay, sir.
Okay.
Thank you, sir.
Okay, fine. So that okay, I just have to okay, very few people are there. So the two things I will just explain, right? One is this one, why that probability at that certain point is 0 and in and around. Okay, I'll just watch the lecture again and I'll try to explain it, okay, in the next lecture. Any other thing I have to do?
I wanted to mention small things to you, sir, on a lighter part. We people are like Katapa kind of people. Without such level of commitment, we can't get our degree, sir.
Like, miss? Okay.
Katappa level of commitment should be there to get this degree, sir.
Okay. Okay. So yeah, but that is okay. Fine. That's see. My job is to like, okay, because why I don't go for any other. So today also what I did is I just tried to do that U into VDV part, right? Actually we did not do in this course because a lot of people here are different backgrounds, right? So they might not have seen that kind of integrations there. So I should not do that integration, but sometimes in a flow I'll just do some kind of things like this. Another thing is yeah, a lot of people, what you're saying is they wanted to get some degree or something, right? So in that case you should not go into like a lot of details. It's sometimes it's only knowing formula and just solving the answer, it's fine. But yeah, that is true. For some people it is needed to know like for them it is need that they have to know everything. In that case I will just try to ensure that whatever things are there, I will try to make sure that that should be dealt in some sessions or somewhere else, and they will understand. I know that, so I will try to do that. Sometimes what happens is in live sessions, right, a lot of things will be happening at the same time. It's not like very easily coming to mind, right? Okay, this thing is happening and I need to give the answer in that flow. Something like that will happen. So sometimes I need to go back and I have to
Sir, may I say something?
Yes.
Yes, sir. Now we have entered into week 5, right? And I think we have entered into week 5, right?
Correct.
I suppose during week 1 itself, I think during second or third lecture when you had come, then we had requested you, sir, that we have 3 sessions in a week, right?
Okay.
So let us divide 6 sessions properly, like 1 session for conceptual discussion, 1 session for activity, and 1 session for solve with us.
Yeah.
This could have done by now. My point is that nothing.
Actually,
you
no.
guys are doing your level best, and we are surviving because of you people only, sir. Let me be very honest. Otherwise, by watching recorded videos, one will not able to solve this kind of question, right?
Yeah. No.
The backbone of this program is live sessions only.
Okay. So yeah. Okay. Fine.
Backbone of this program is live session only. If live session would not have been there, I think most of the people would have dropped, or at least I would have dropped.
Yeah. Okay. So yeah, that is okay. So the another part is what you're saying is
because if I have to watch recorded videos, then I will go and get free of cost in NPTEL, sir. Then why I will invest 3.5 lakh money here?
Yeah. That's true. So
we
yeah,
have
we
come
also
here
yeah.
So this kind of organized structure has been provided by now. But what is happening every time when instructor is coming, so we have to request the same thing, sir. Okay, today let us discuss concept, tomorrow let us discuss activity question, and third day we have discussed. That is the only request, sir. Now you are running the show, sir. You have to take a call. We can only put request, right?
Correct.
Like we put the request to cancel the session on Sunday, you people cancelled it. So we are thankful to you that we have been traveling so much. So how we will attend session on Sunday, right? So you considered that request. I think Srikanth sir was there on Friday, and he considered the request, right?
Okay, yeah.
So
yeah,
are very helpful.
what we are trying to do is here actually, we are going to have I think 4 or 5 sessions in a week, and in that 2 sessions will be 1 hour each in a native language. Actually, we are trying to do that one. Actually, see, what you are saying is correct only. So for understanding that need, right? So certain sessions will be dedicated only to some whatever you're saying, right? Just
conceptual doubts. So
conceptual things.
Yes,
Yeah.
While discussing the conceptual doubt, we can discuss activity questions, right? So that will that will have a compounded effect. That will have a compounded effect.
That's what we are trying to do. Yeah. So and we are trying to do in some native languages like Hindi or maybe
I
some
don't think that
sessions.
how much this will help us because
I don't know.
Even my communication skill is not good. But when we are aspiring to be a data scientist, so we have
to English.
Learn
Yeah.
that also.
But sometimes what happens is like understanding in English, right? It sometimes it will be easier in some native language. Sometimes it will happen. We are also trying. Actually, we are also trying.
That's right. You people can have that.
Yeah.
But the point is this, sir, please have, because statistics is the backbone of data science. Sir.
Correct.
And we have heard so much about IIT Madras that IIT Madras is pioneer in statistics. I think the R server was installed for the first time in India in IIT Madras only, right? If I am not wrong.
So yeah, so what we can do is, okay, what we'll do is, in one session, right, every maybe in first session will be there in a week, because a lot of people won't be studying in that week. Most of the times, like very few lectures they have studied. So
let
in
us
that time,
devote first week itself for conceptual
correct.
discussion.
First, yeah, we'll do that definitely. So first session will always be like this only. Maybe 1 hour or 1.5 hour will be mostly whatever is there in that week, and then we'll try to solve. Or along with that, some questions will be there. Like that, we'll try to solve.
That's better ideas.
If, sir, if the instructor drives the session, sir, a session of 2 hours is more than enough. I have a logic behind this, because in any week we are not getting a video content of more than 2.5 hours, right?
Right.
We are getting 4 to 5 videos, and the
Right.
entire duration of those videos are 2.5 hours, or less than that, or sometimes it goes up to 3 hours. So while you are explaining, you will not be explaining the entire video in length. We will be discussing only the critical concepts. So a 2 hour session will be more than enough, sir. But now let us give a structure to this. What is happening now? Today we are talking to you with very humble, very politely. I am saying this. Tomorrow someone else will come, and he will come with a complete blank sheet.
Yeah. No, see,
So this is not getting communicated among you people, sir. It's
Yeah.
not getting communicated among you people itself.
Okay. No.
Sir, when we are having this solve with this.
Actually, so today was the solve with us one.
Yeah.
Right? So maybe we. So
Tomorrow
if
we have a
I'm.
session, sir. Can we have tomorrow?
No, sir. Tomorrow, no, sir. Please. Day after,
No,
sir.
one minute.
Thursday.
We'll
And
check
session
the
has been scheduled.
calendar.
I am not saying session has been
So,
scheduled. Yeah.
so this tomorrow session, actually it is scheduled as open session week 6, right? And one more session is there on Friday, which is activity or practice session week 6. But Friday is having you guys are having this
Deadline,
deadlines,
sir.
right?
Yes, sir.
Okay. So maybe, okay, I'll talk to my team and we'll reschedule all these sessions again. So maybe okay, solve with us will be
We can
there.
have a solve with us on Thursday, sir. Like
No, but Thursday we have one session is on Python is there, and
so anyone else can take it.
someone is no, it's not like that. I anyone can take, that is okay, but the problem is if somebody is there in Python session, right? So Python subject, and somebody has taken statistics too also, so he or she might not be able to attend that session, right? Okay, we will see. If not Wednesday, then we can have one session on Thursday. But what will be the timing?
Anyhow, this week we have missed a
So
session.
6 o'clock, sir. Thursday 6 is fine, sir.
This week we have missed a session.
Please.
But okay, Thursday 6 o'clock we have statistics one session. So statistics one you have to complete, right? If you are coming to stats 2, that means if it is clashes also, it's not a problem, right? Okay, that will be done. Maybe we can have one session on Thursday that solve with us. Okay, that is okay. So can we? Okay, week 6 is released, right? Already.
Yes, sir.
Release, sir. We will start week 6 from Friday itself, sir, because that is the first session for week 6. Right?
No. First we'll complete with this, sir. The
Yes,
week 5
we
will complete with the assignment.
Yes, that's what I'm saying. We have to complete week 5 first, and then we'll go to week
Yeah. Because week 5 the deadline is on Friday. So first we'll finish off with that, so then we can start with week 6, sir.
So maybe we can reschedule one session, like solve with us week 5 on Thursday 6 to 8, and that Friday session we can move to Saturday maybe.
Yes, sir.
Right?
That will be fine, sir.
Okay. Well, I'll talk to the team, or maybe Friday session will be like we'll keep as it is, and one session tomorrow session will move to Thursday.
Yeah, like that will do, sir. So Thursday we can do solve with us. Friday evening, whatever the doubts if they have on week 5, they can just clarify that.
Okay.
Submission day, no?
Yeah.
Okay. Anyway, see, because we have one more session on Sunday and then we have one more session on Tuesday. So Tuesday will be solve with us,
That's
right?
only for week 6, sir. That will be for
Week 6. Yeah.
That is
So,
okay. That is okay.
So week 6 should have a sufficient sessions, right? So maybe Tuesday we have, Sunday we have.
Let us not disturb week 6, sir.
That two sessions will be like that, and tomorrow's session maybe we can shift it to Thursday or something. Yeah, that will be okay. Maybe.
When is the results coming, sir?
Results maybe it should come actually within maybe 2-3 days, most probably. Today's Tuesday, right?
Yes, today's Tuesday.
Yeah, maybe Wednesday will actually we also didn't get right now, so maybe tomorrow we'll get, and if we'll get tomorrow or day after tomorrow, that day will release. Okay, maybe 1 or 2 days, not more than that.
Thanks, sir. Thank you.
Thank you, sir.
Okay, sir.
Okay, guys.
Once again, thanks a lot, sir.
Yeah, thanks. Thank
Thanks,
you, guys.
sir.
Thank you.
Thank you for all
Thank
the
you,
live
sir.
sessions. Sir. Thank you.
Okay, thanks.
Thank you, sir.
Good night.
Next, sir.
Thank you, sir.